we're good to go.
Hello, chat. Welcome to another stream. What about it? What about it? I'm not Anthony. I'm not your host. I'm an imposter with a higher Spanish accent. It's just like Spanish Anthony.
My Spanish accent is terrible. My Spanish is terrible, so I won't I won't ruin it for you.
So I was trying to say. I was trying to think. How do you say like any of your tools in Spanish version? But like I suddenly realized that since I've been speaking in English for professionally for all my life, almost. Like now I don't know how to fucking say those things in Spanish. So I don't know. I'm not going to embarrass myself. Jesus.
Like get commit in
All right.
Spanish.
Yeah, and I don't think you can like commit. It's like, yeah. No, this is the thing, right? If I'm talking with a Spanish friend, I will say comitear, which is like committing, but like you end it in the Spanish version. But you like the same thing as share pointer. So share pointer, you translate it. That one I know. You will say puntero compartido, no? Puntero pointer compartido share. But like it sounds so fucking weird
Yeah.
because it's the fact. I mean, I think I can explain it. It's when you say the group, the band, the Doors.
Yeah.
You don't think about it means the Doors,
Right.
but like if you fucking translate it, it becomes so obvious. Like the Doors, like what a fucking
Puertas,
name.
like
Yeah. But yeah. You just don't think about it. Okay, the Doors. Okay, cool.
Awesome. Well, welcome, Pablo. Today, the start of the plan, the concept of the plan is we are going to look at the new sampling profiler that will be landing in Python 3.15, and I believe its code name. I'm going to say this wrong. Is it Tachyon?
Yeah, Tachyon. Yeah. You know what it means?
I don't, but I actually have a funny story about a very similar word. There's a word in English called stanchions. And I remember it was a vocabulary word in high school, and no one said it to me out loud. And so I was the first person that got called on to define the word stanchion. And I thought it was pronounced stankion, and I barely lived that one down in high school. But what is a tachyon? Explain it for us.
Yes, it's a very geeky reference, I suppose. So a tachyon is a hypothetical particle that goes faster than light. So in general relativity, okay. So special relativity tells you like, you cannot travel faster than light. So you say, oh, okay. But in theory, the only thing general relativity, which is the best version of it, says is that if you travel either faster or slower or at, you cannot move to the other two. So like if you travel less than the speed of light, then you cannot travel either at or faster. But it doesn't say anything about like, oh, you cannot travel faster. It's just like so of course we have not seen anything traveling faster than light, of course, but like we have to put names to it. So we call it tachyon. So this is just a very long stupid story to say it's just a very fast profiler.
Nice. That is great to hear. Python 3.15 is faster than light. I might be wrong.
Wow. Well, no. Python is still slow. Okay, it's just the profiler is the profiler that is faster.
Nice. All right, so I'm gonna jump into. I hope this scene still works. Oh, fancy scene switch there. All right. Wow. So, I think I want to just start by reading the docs because I haven't looked at it at all. And
yes, let's do that.
Let's do that. Okay. So I was doing stuff earlier. Oh, that tab I actually need.
We have worked really hard on those docs so far. Like this is a pretty chunky document, but like, and it has this cool logo.
The logo's at the top. Nice.
Wow, cool logo. It's the logo by Mike Jimenez, who also did the logos for 310 and 311. And apparently now we are also doing 315, which is not by Mike Jimenez, but of course it was inspired by those logos.
Sweet.
The pie thing. Yep.
Awesome. Who did the memory one?
The memory one, I think it was not Mike Jimenez, but it was like an artist that we hired. Okay. I think it was called Jonathan Smith or something like that. Very cool one. The snake on the same guy also did the pie stack one, which is this like snake with pancakes. But if either he was less inspired in that one. The snag on is very cool.
Pancakes with Python is great.
Well, it's pie stack, but like I think we put him in a creative corner because we said, okay, the tool is called pie stack. So we want a snake with pancakes because, stack of pancakes. And I think it was like harder because with memory, he was like, okay, what is this? And it's like, oh, it's a memory profiler, but it needs to look cool, but with a snake. And he's like, oh, a snake dragon. He's like, all right, let's do it.
Easy.
Let's do it. And like it was very cool. But with the other one, he was more in a corner.
Yeah, forced from the idea was incepted early on, so he was incepted. Is that even a word? So he was stuck there. Okay, cool. So the profiling.sampling module named Tachyon, blah blah blah, statistic profiling. So I have a concept of statistic profiling in my head. I'd like to hear what you think about it and like how you describe it to people.
Let's see. Exam. Call an interview.
So in my mind, when I think of a sampling profiler, it's you have like kind of two kinds. One being a deterministic or
tracing.
Yeah, tracing profiler. Yeah, versus a sampling profiler. With a tracing profiler, you're like injecting code before and after function calls or statements or some unit of code. And so when you run it, you get a deterministic amount of function calls, but you have a sometimes significant overhead to running the code. Whereas sampling profiler, you're kind of analyzing, you have a separate process that's reading stack frames at some periodicity and then recording what the stack trace looks like at that point and then inferring the amount of execution time based on those.
Yes, that's exactly right. If you allow me to become my alter ego, pedantic Pablo, I will pedantically clarify that in theory, sampling doesn't need to live externally. It can live in the same process, and indeed, also sampling normally is associated with no overhead or smaller overhead. Doesn't necessarily mean no overhead. So, for example, almost ever, like that's another thing that we can talk in this stream because that's a very interesting topic, the overhead of this. But for instance, in C++ land, the way normally this is, it used to be done long ago. Now that we have bigger tools, it was that you register a signal handler and then you will periodically send in signals to the process, and then the process will kind of dump the stack or whatever in some socket or whatever it is. So in theory, you will impact the process, but you can imagine that the signal handler can be a thread or whatever it is. So
right.
Or response a thread or something. Yeah.
Okay, makes sense. Yeah. Is the sampling profiler in 3.15 implemented like in process as a thread, or is it a separate process?
It's a separate process.
Okay, makes sense. I mean, sort of follows up from the stuff you did with the debugger, I assume.
Actually, no. I mean, yes. Excellent question. Yes, in the sense that it uses the underlying technology, but like not the same technique in the sense that the debugger needs to learn how to read a bunch of like internal structures and whatnot. But the way the debugger protocol works is not the way the profiler works. It's just like it shares a bunch of code because both need to kind of read internals, but it doesn't. In theory, the profilee, like the process being profiled doesn't know that it's happening. While with the debugger attachment protocol, you are forcing the process to do something. So of course it will know that something is happening. You need to collaborate. But the beauty of this is that the process that is being profiled, 99% of the time doesn't know that something is happening. We can talk about the 1% later as well. Secrets.
I'm kind of interested in that 1%. We'll get to that. But yeah, I guess that clarifies to me that like it's not injecting code to dump the stack. It's reading it directly from the memory.
No, it's not injecting anything. Yeah.
Cool. Awesome. So that definitely means the like virtually zero overhead part of it.
Exactly. Yes. It's very cool to like we can talk at any point you want, but it's very cool to talk about where the overheads come from because it's very unexpected. Yeah, it's very small. Like you will not even notice it unless you go really, really bananas. But like it can happen.
Really bananas. Speaking of bananas, I hear you have a particular bit about bananas.
Oh yeah, the PyCon talk, you mean?
I saw the suits. Like, what inspired it? What? How did that come
Oh,
about?
I can tell you the hidden story. So we were at the Python core developer sprint in Bellevue in the Meta's offices, and we were having dinner. I think it was Guido, Yuri Selivanov, Lisandros, Emily, and myself.
Hmm.
So I these days less, but I used to say a lot this expression. This is bananas, or like this is fucking bananas, or whatever. So I don't know. Like there is a subset of core devs that find it hilarious for some reason. I don't know. Maybe it's the Spanish accent. I think I think the way it went, it was that Guido said something like, "Oh, you say this a lot. You should give a talk dressed like a banana," and then I was like, "I will do it if you do it," and then he was like, "Oh, I'm game," and I don't think he took that seriously, right? He was like, "Oh, haha, stupid Spanish person," whatever. But then so we kind of like, this is the thing, right? Okay, I can give you also the hidden thing. Okay, so that's
Yeah.
what happened, and then I start to conspire with Gukish Lange and Yuri Selivanov, because there is this thing when people believe that core developers are kind of like gods or whatever, and I just fucking hate that. Like I just hate it. Like
You're
it's
just
just
normal
no, I don't
people.
like it. Yeah, it's just fucking dudes or like girls or gals or whatever, right? Like it's just whatever, right? Whatever. It's just people. It's random people doing whatever, but it's like it's like this weird like mystique or whatever it is. I just hate it. I hate it. So my objective was to humiliate us as much as possible, so everybody knows that we're just clowns. We are a fucking circus. That's what we are. The fucking circus. So okay. So I said, okay, how can we like do this? So say, okay, let's do a serious talk about like a real serious topic, because this is the thing, right? If you go to PyCon and give a talk about like bullshit, then okay, yes, you're a clown. But here, you still need to make the talk useful. And
Right.
there's a funny story precisely about this in a second, in the talk. So we said, okay, let's give the talk, talking about like this mega thing that we did, this async.io introspection, blah 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 blah, which like it's kind of cute, it's useful, it's not groundbreaking, but it's kind of useful, but technically it's really really hard.
Yeah.
And it was like such a fucking big PR, whatever. So we said, okay, let's do the talk dressed like a banana. And then PyCon US said, only two people, no more than two people in the stage.
There's stupid
And then it
speaker
was like,
requirements.
right, and then we say, damn. So we say, okay, we will be Yuri. It will be Yuri and me, and then we will do this thing at the end when it will be a stage. So Gukesh will pretend, it will be normal like a normal person, but in the last 5 minutes, he and Guido will go out, and then he will dress again like both will dress like bananas, and then Gukesh will come in and ask the question, all planted, obviously. Like it's obvious because he's dressed like a banana, and then he would say, "Oh, this is kind of cool, but like, what's the creator of Async.io has to say about all of this?" And it's funny because a lot of people think Yuri is the creator of Async.io, but that's not true. He's the bigger maintainer, or like a very very important person in Async.io, but it's not the creator. The creator is Guido.
We don't. Yeah.
So then Guido appear. The plan that the Guido will appear. And he will say, "Oh, this is totally bananas," and that's the way it closed. Man, we were so nervous because apparently Guido was lost. so,
Oh
so,
no.
so, so, yeah, yeah. Lucas was like trying to find him for how to talk. It was, but we managed to do it, and we have these stickers. I don't know if I have any here. Probably not. But we have this sticker that says like, "Go watch the two core developers go bananas" or something like that. And
That's
like
awesome.
we spam the entire PyCon. You just went like giving it to everyone. So yeah, it was a funny talk. So that's the origin of like the bananas. It's just
Nice.
how we can look like clowns. But like,
Perfect.
but the talk was very technical, and we were like going out of the room, and it was this guy who I don't know who this guy is. I just eavesdropped the conversation, and he was saying, for how ridiculous the talk was, it was surprisingly informative.
So
It's
you
like,
you
yes,
succeeded
yes,
perfectly.
yes, that was the idea. Yes, success.
Awesome. I have an important question for you. I actually have a banana with me right now. Um, do you open a banana from the bottom
No,
or
no,
from the
no, no.
top?
For the top is optimal. The top
Okay.
is optimal. Yes, yes. There is more. There is more. Shell. How do you call it?
Uh,
Like there is more moment. There is more momentum.
yeah.
Like you can. The,
S-
the, the, the distance plus the momentum, it has a higher value. I don't know how is that in English. I forgot.
Yeah, the fulcrum point is better or
Torque. The
whatever.
torque. Yeah, the torque.
The
Yeah, more
torque, yeah,
fulcrum.
there we
Yeah,
go.
yeah. Yeah, there is
Um,
more torque. Yes.
so I have an admission. Um, I am a psychopath. I
You open it
actually
from the bottom? No,
I open it
no.
from the middle.
What a beast! What a beast, dude. Horrible, horrible. Jesus Christ, man. Okay, I can see that it's very pragmatic, but like, Jesus,
It only works with
that
like
has to
Korean bananas.
backfire. No,
Oh, it
that has to
does
backfire.
occasionally. If they're like really,
Yes,
really
yes.
ripe, it does not work.
It's like the loot box of the fruit kingdom. Like it's like what? Will this explode in my? It's going to explode.
I have definitely had a few times where like it is like weirdly mushy in the middle and it just gets all over me.
Yeah,
And
exactly,
like,
exactly. I was thinking about that, or like it's particularly slippery, so you just squeeze it and it just like
I have
goes
also
bananas.
done that. I also I finished a half marathon recently and the banana was frozen, and so when I broke it in half, like it shattered, which was weird. So I had like random shards of banana, like frozen banana. But anyway. Cool.
Right.
Okay, I did my banana bit. We can actually
Sorry. Yes, yes, yes. No. Totally, totally.
we got a
Has
good
to be
question
known.
from chat actually, which is from Dream Shaded, who asks, "What's the difference between the built-in sampling profiler and popular ones like Austin?"
Good question. There is some less difference than with other profilers because it's the same technique in it's a technique that was originally spearheaded by Ruby Spy, which is the Ruby sampling profiler by Julia Evans, which also has a bunch of magazines that are very cool. You can buy somewhere in the internet. So she started Ruby Spy, which I think is probably like Ruby Spy because there's no vowels in the name or whatever. And then
There is no
yes, and
vowels, you're
then
right.
I think no, it's Ruby Spy. Yeah, yours Ruby Spy, Ruby Spy.
Rib spy.
Cool. Yeah, Spy. And then I think it was Brendan created PySpy, which was the Python version in Rust. I think he was learning Rust. It was his first project in Rust.
I've used that one
Using the
a
same
bit.
technique, except that Python makes this really hard. We can go into why in a second. And then a bunch of profilers started to do the same, like Austin, for instance, and whatnot. So it's the same technique. It's just that Tachyon is faster. Why is faster? Well, I mean, it's faster now. Probably at the time 315 is outside, it will be as fast as any other, except maybe PySpy, because PySpy unfortunately is
Kind
lagging
of
a bit
dead.
behind. Well, yeah, I mean, it would be a bit unfair to say, but yes, like, I think it's just that unfortunately he has not a lot of time to maintain it, and like as you can imagine, keeping up with Python is challenging.
It's
So yeah,
especially the low level parts of Python that
yes.
change a lot.
Well, it's also that this is the thing, right? Like it's also that when these profilers started, you need to reverse engineer kind of, we can go into exactly how, but you need to reverse engineer what the interpreter is doing. So it's a very aggressive operation when the interpreter like gives you zero guarantees of anything. So basically, not even in patch versions. So it's just hell. So I have actually made a bunch of changes in the interpreter to make this easier for everyone. So the interpreter now exposes in a secret API that nobody else knows apart from the profilers, people exposes a bunch of information. So technically, you don't need to reverse engineer stuff. You can kind of read it from it. The Bagger protocol now also uses that. So now it's a bit easier, and there are some guarantees on that. The main difference with both Austin and PySpy is that I control the interpreter, haha, so I can do a bunch of tricks that they cannot. So of course, this means that, for instance, Austin, which is it keeps more track of like what's going on, is a kind of updated, and I support 314, for instance. Of course, like it's backporting. Well, backporting. It's adapting to these changes. So in theory, there is nothing that Tachyon can do that the other the other profilers cannot do once I expose those things, of course. But the idea, of course, in particular for Tachyon is not particularly to be fundamentally different. It's just first built in, so it's just offer a reliable experience. And then the other thing is that to offer kind of a template for everyone else. So because like when 315. Sorry, when 313, for instance, came out, everybody needed to reverse engineer back again how the fact, what Mark Shannon broke this time or whatever. And in this case,
not to name names, but
right. Well, I mean, it's not Mark Shannon or me. Okay, it's both of us. What about that? It's both of us. The Spaniard and the Brits. Sounds like a bedtime story. The Spaniard and the British. So yes. So in this case, you can just read tachyon and see what the hell. So that's it. You don't need to guess or like words. Sometimes we broke things in ways that you cannot go around. So it's just like so that's bad. So tachyon also ensures that. Especially now that we are optimizing the interpreter a lot, like we don't break in introspection. So that's the other thing. So yeah, that's how it compares. In theory, it's faster now, but again, it's not because like we are like secretly smarter than anyone else. It's mostly because like we have the unfair advantage that we also control the interpreter.
Yeah, you can add the instrumentation that you need and keep it working over
kind
time.
of like in the sense that yes, but like you need to convince all the other core devs, and of course, instrumentation is not like you will only use it when you profile. So if it somehow makes the interpreter slower because you have that thing or more difficult to maintain, it's just a political battle.
Right.
So it's not like free lunch. You know, I could do a bunch of cool things that unfortunately won't fly because it will make Python 0.1% slower, and I'm like, no, it will not happen or whatever. So I need to choose my battles delicately. But yeah, that's how it compares. I have to say as well that also Tachyon has a bunch of at this time new cool visualizations that other profiles don't have. So that but they could add it. Like I don't think it's particularly special. I you know, like it's just something that can be easily added to other profilers.
Sweet. Hopefully we'll be able to look at some of those visualizations as we jump into it later. We got a follow-up question as well, which is, are there plans to add memory profiling?
Maybe.
Also,
there is already memory profiling. No, there is trace malloc. It's just that it's not probably what you want because the overhead is too high. What you want is like some kind of like statistical memory profiling, but that's a bigger beast.
Yeah. Do the like instrumentation things added for Tachyon help things like Memray or other tools?
No. No, actually no. Memray in particular, no. It helps mostly the profilers in all the different ways. So anyone using profilers or maybe the baggers as well. But like mostly those tools. Memray in particular lives in process, not outside the process, because memory you cannot do unfortunately from the outside, or at least easily. I suppose some tools that are like semi-debuggers, but like it's mostly like PyStack, for instance, a debugger, sampling debugger. It's kind of like a profiler, but like it just takes more time to gather info. So it does the same thing. It takes a sample of the stack. It's just that like it works in many other cases when a profiler wouldn't, like a core file, for instance, or it gives you locals. But like it kind of like takes its time to like gather as much info, so it just stops everything, gathers all the info. You know, a profiler wouldn't be able to operate that slow because like it's not worth it.
Right.
So it helps those tools as well. Yeah.
Cool. Makes sense. Awesome. I'm gonna scroll through the docs just a little bit so I get an idea, and then maybe we'll try and profile something.
Yeah. No, let's try and profile. Yeah.
Okay.
So just my idea, at least, just for everyone maybe to be on the same page, and we can adapt to whatever your idea is, Anthony, is that I want you to like at least look at this, of course, and like let's profile together a bunch of things. We can I can show you a bit like what it does and whatnot. We can even like read a bunch of here, but maybe something that we can do is that we can have a small profile and then we try different things. And then I just want you to know what you think. So think like, it will be cool if you do blah, or like this actually is a stupid idea. So, feel free to just go bananas and say, what a bunch of idiots. Like, as you know, it's very hard for us to get real, like, feedback.
Practical feedback.
So please go all the way. So like,
okay.
you just say, this is fucking unusual or whatever. So we or like the CLI, I don't like the CLI, whatever it is, right?
Yeah. I'm always going to be candid with the things that I say, unless I'm legally obligated not to be.
You have the magic ticket. So
perfect. All right, let me make sure
I have 315. Do you have 315 around?
I was about to say, let me make sure that I have 315 in the first place. I do. I have Alpha 5. Is that going to be new enough? Probably.
Yeah, at least for now. Like, can you do?
I can get newer.
Yeah, if you don't mind compiling just main locally, if that's a possibility, just so we can try the latest things. Otherwise, we can do alpha 5 until we run into the new stuff. But like, I think, or you can use nightly. That works as well.
Yeah, I was gonna skip compiling. Just just get nightly because that'll probably be easiest.
All right, I forgot that you maintain the snakes.
It helps sometimes.
Half the internet, Anthony. Half the internet is maintained by you. Do you maintain DNS as well? Is the DNS also
It's
maintained
me.
by
Yeah, I manually set the A records. You know, no, I wish I maintained.
That's why it takes so much because you're hacking in other projects.
I'm doing the TTLs manually by hand.
All right. Okay, let's.
I actually wish that I maintained less stuff. I feel like I'm spending too much time on open source, but okay, this will give us CCBE, which
I think if you maintain enough stuff, you can get into the famous image of like all the blocks and like maintained by a guy in Nebraska. Like what nobody knows is that you are the guy.
I'm the XKCD comic.
Yeah, there is a little one maintained half of the Python ecosystem you assume.
Okay, right. So we have yesterday's build. Is that going to be new enough?
Yeah, more than enough.
All right.
Okay, so I have a bunch of ideas on like how we can start. Some of those are like stupid things to profile, but like we can go into more real ones. We can try your editor later. Okay, so first, let me kind of explain. Cool. So the thing you will write this is, as you said, -m profile and sampling. I know it's very long. I have think about trying to argue for a binary name in /bin, so you can do tachyon. It's the same way you will pip. As you can imagine, that is not going to be easy to get. But like maybe. But I know it's long, so unfortunately we are going to have to do that. Okay, cool. So tachyon supports 2 main modes. So the idea is that you will be able to kind of like run like the getting things from the profiler in my kind of like approach is that getting things from the profiler should be easy. So a memory, if you recall, you need to run and then it produces a file and then you use the file and like blah 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 and like
do a bunch of steps, right?
Yeah, so here you can kind of do that these days because I added a mega ultra super like binary format that is ridiculously compressed, but it was like, nah, it's complicated for the base. So tachyon run is the most normal one, so that you can pass almost any Python invocation, so either a module or a script, and that works. So for instance, let's do a very easy one. So you do Python 315 provider sampling and run. There's a lot of shit, but right now we are going to do dash flame graph. So do, for instance, dash flame graph. In the invocation.
Does that have an output file?
Yeah, and then you do -m for module, and then it's like this is like if you do Python -m.
Yep.
So yeah, and then let's say test, and then let's say for instance test list, for instance. So test. This is the now you are like invoking Python, right? So -m test, and then test list in a space. Yeah.
I need to install the test suite.
Oh, because you do the Debian thing? Oh.
Yeah, I do the Debian thing.
Evil.
Is it libpython test suite?
Yeah, it's libpython 3.3 test suite. Yep.
Yeah. Okay. We'll get.
And all these files are so big, like impossible to store at the same time. This trips me every time because I think the Debian people leave one single file at least for the test. So it just says something like, "Oh, I don't find like librec test or whatever," but it doesn't tell you like, "Oh, I don't know what test is."
Yeah, they don't. Well, they also don't run the tests as part of packaging, which is fun. Okay, we have test list now.
Yes, I put a space between test and test list because like, that triggers the internal. Well, that works as well. Okay, cool. So you see, like, bam, there is an HTML file. Bam, 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 bam. Like you don't need to do anything else. Like you can open that file.
Okay.
Wow. So you can
actually that's file. Really nice because fighting with what is it, flamegraph.pl, I feel like is always.
Yes, no bullshit. It's just like open the file. So if you open the file, okay. So now, wow. Okay, so there is a lot of stuff here. So it's a flame graph. I mean, I suppose you know.
I've used a flame graph before. Yeah.
Right. So for the people in the chat that are not used to flame graph, haha, screw you. Go and read. It's a cool format, but as you see, there is a bunch of like interesting parts on the left side. So some of the things that you can get from here in the bar on the left is very quickly, if you scroll up a bit,
Yep.
is that how much time you need to, yeah, there you go. So how much time of the runtime in runtime stats, how much time of the runtime is basically the process has the guild held, how much time of the runtime the guild is released. We can in a second do some experiments just so you can see, and how much time is running the GC and how much time is just handling exceptions. So you
Garbage
can
collector
get
time is
there.
actually huge. This is always something that I have a really hard time finding in other profilers.
Right. Well, you will see something very cool in a second. But like, yes. Let's do that next. But like, the idea here is that you can quickly see if the program is IO bound or not, depending if it has the guild or not. And
Right.
then there's a bunch of stats about the profiling itself, like how efficient and whatnot. And the thing. Of course, you get like the hotspots. So you click one of those hotspots, like for instance, the share-based context. It
Yeah.
says that like in the bottom.
Ah.
So you click one of those cards, it will hopefully highlight so it will highlight the thing.
And
Of
points you
course,
at the
that's very
code
obvious.
too. That's pretty cool.
Yes, yeah, and that works. So the idea as well is that all of this info is embedded on the HTML, so you can send this HTML and put it in GitHub issues or whatever the hell it is, and you can just send it around. So you don't need to. Like, it doesn't read anything on your machine. It's also it's fully self-contained, so you can also open it offline. You don't need internet.
I
You
shouldn't
know
have tried to
you
open in my editor because it just crashes, but
yeah, well,
okay, it's entirely
literally, yeah. So in theory, it's just full of everything. Not super chunky, slightly chunky.
less than a
So
meg's not
like,
bad.
yeah, it's okay. I mean, it kind of like is smart about it, so it doesn't. It just strips everything that is too small. So like, if your profile is made of 6 bazillion mini functions, it will just select the ones that are most of the runtime if it can. I mean, I have seen some edge cases when it gets like 10 gigs, I think it's 10 megs or something like that, but like it's fine. It's mostly self-contained. And of course, here you can like click and you can search a bit as well. I think there is a dark mode in
There's
the
a
top
dark
right.
mode.
Yeah,
Oh, you
yeah,
have to
in the
have
top
dark mode.
right.
Oh, it's really dark though.
Yeah. Sorry, I was checking the stream. Yeah, there you go. So there is dark mode, and then there's a link to the dorks. Yeah, and then I think there's a mode when you can like use the system thing where like if it's dark mode, like you have configured dark mode in the system, it will just use it.
Yeah.
It will put a cookie so it remembers your selection for further
Nice.
profiles.
Nice.
um
That's all
and
very
then there is
cool.
the heat map kind of thing. All right, so of course this will be kind of, or I hope, the most typical kind of like format that people will use if you are used to flame graphs. Here of
Yes.
course it will tell you, I mean, it's kind of obvious from the format, but it will tell you your parents and your children and the self call, the percentage that is the self call and the total call, which can be obviously seen from the shape of the flame graph. So that's one. Okay, now it's time to be very impressive. Let's go. Let's go to impressive in a go. Okay, so go back to the command line.
Yep.
So you are going to write the same. Let's do the same thing. Yeah. So the same thing, but instead of dash flame graph, do dash gecko.
Gecko, like the
Gecko,
animal.
gecko, like the gecko, the animal. It's like
Okay. Yeah.
yeah, gecko. Yeah. Okay. So run that thing, and it's going to create a file, and it's going to tell you to open the Firefox profiler. So open that thing, and then either open that file from the Firefox profiler or drop the file in. I think you
Okay.
can drag and drop. You can drag and drop or load. Yeah.
I'll
Okay.
just
That's
find it somewhere. I gotta find it on my system.
yeah.
What is my
You
working
can probably
address?
do now. I like to do Nautilus dot, and that opens the files in the place.
Yeah. Yeah. I got here anyway. It took me a bit.
All right. Yes, I'm following also the stream like slightly delayed. So cool.
Ah.
So this is the Firefox profiler, which is like a much more powerful visualization. So here, if you click, for instance, flame graph, the flame graph tab, you see that flame graph, but now you also have the timeline. So you could select like an area of the timeline, and it will create a flame graph only for that particular area. So for instance, select just an area at the beginning of thread, blah blah blah, and then it will generate. It will change basically everything based only on that selection. So you can know what was happening only on that. So you can imagine that you can have a program where like it is by model or whatever. So it does a bunch of things at the beginning and then it does a bunch of things later. But you can select your flame graph on a specific area of the code to know what the hell is going on there.
Wait, this is crazy. So then you could like ignore the startup and tear down the process and just look.
Yes. But you want the magic trick? You want the magic trick?
I mean, this is already my mind is already blown.
I'm going to destroy your head. Click marker chart. Marker chart. So you click marker chart.
Yeah.
It's on there you go. So wow, look at this. So now you can see a timeline of what that thread was doing. So you can check if he's running native code, Python code, if he's running the GC, or if he has the GIL or has not the GIL at the time. So
wait, that's so cool.
Yeah, so let's do something very cool together. So go to your terminal.
Yep.
And let's write a stupid program together.
Okay.
So let's open Bobby or whatever, and let's write a program that spawns through threads that are just doing some math bullshit, like adding a number in a while loop and then fighting for the GIL.
Okay.
So. Yep.
I don't know. Well, that'll probably get too big too quickly.
That doesn't matter. Like we're going to just do it for 2 seconds or whatever. Yeah.
No, that actually does exactly the same thing. We'll just add a number. Yeah.
Yeah. No, that's fine.
Man, I haven't spawned a thread in a while.
You can t1 equals threading.thread, and then in the constructor target equals the name of the function.
Yeah, and then dot start.
And then start on both and then join on both. Yeah, and then you can copy. Yeah, and then there you go. On T1, T2, and then join on T1, and then join on T2. You only need one thing. All right. So then, so because it's a while loop, they're going to just spin forever. But if we go and okay, so we go to the command line and then now run the same thing, but instead of -m test list on the invocation of the profiler, we are going to pass the script, and then also before the m, because after the m is just like the m is just a module, so you can just do the
either way works. I'll do it the script way because we haven't done that yet.
Yeah, but then before that, do -d3. That's like just profile for 3 seconds.
Okay.
And that's before the name of the script. Yep. -d3. Yep. So that will profile only for 3 seconds. Okay. So now same deal. We will have a file. Drop the file on the Firefox profiler and then go to marker chart. So ideally, yeah. Oh yeah, that works as well. I think you can just drag and drop the file.
Should be this one. Cool.
So if you go to marker chart, in theory, we will see the 3 threads from fighting. So go to marker chart. So I think you can. This is a bit bad, but like if you. Oh, okay. Sorry. I forgot. You need to pass -- all threads to the profile invocation, because by default it only profiles the main thread. The reason being that if only you are interested in the main thread, which is, by the way, most of the time people only want the main thread, it activates a bunch of optimizations, so it's a bit more efficient.
Makes sense.
But if you throw -- all threads, you can profile all of them.
Oh.
And,
whoa.
And then you click there, and then you can see that you can see if you kind of like you make a selection of the timeline that is a bit smaller, so not all the timeline. You will see that the GIL is basically being bounced by the threads. And like if you click different threads on the Python, like when you see the threads in the timeline, you can click different threads over there, and you will see the kind of like the things. So the main thread is just waiting is just chilling out, but these two are constantly fighting,
bouncing back and forth
for the GIL. Yeah, and you can see how the GIL is basically being shared between the two, and of course, like when one has it, the other doesn't have it, and you can see that is waiting for it.
That's super cool. I assume the sampling I assume the profiler works with the free threaded.
It does. Yeah. So we can run the same thing with free threaded and see what happens. That's an excellent idea, which I have never done. So I don't know. I don't know if it's going to work.
I've never done it. But uncharted territory here.
Yes, I mean there are tests for this, so like it should work, but I have never I have never seen this particular visualization with pre-threaded, so
Let's see what
I
it
don't know what
does.
we'll find.
Okay, so we can
Now
also.
I'm very curious. Live, like you're seeing it here. Okay, market chart. That's okay. Okay, yeah, exactly. So that's what we expect, no? Like
Yeah.
the two threads have the GIL and the other, yeah, exactly. So it's running Python code on CPU. Yeah, exactly. Okay, cool. Amazing. You
It
saw it here. You
works!
saw it here. Wow. Okay, do you want to blow your mind?
Yeah, we do have one suggestion from chat that is there should be a flag to automatically open the profile in the browser. But I'm not sure how that would work because you kind of have to give it a file, right?
Yes, I think you can. So the problem of the file is that it can open a URL. So like if the file is uploaded in a gist or whatever, they can open it. And unfortunately, you can open the Firefox profiler locally, but like it needs to be in server mode.
Mm.
But like I don't want to embed the fucking Firefox profiler on like
Yeah.
Python.
Yeah.
I think there is a trick to like trick the Firefox profiler into opening like a file, because what you can do, what is the trick? Is like you can start an HTTP server, like
Mm.
and then you serve your file, and then you trick the Firefox profiler into contacting like localhost or whatever.
Ooh. Yeah, that could work.
Something like that. I think Sampley, which is Sampley is kind of a profiler for C++ and like Rust and whatnot, that also works recently with Python, using my integration with perf. So that uses the Firefox profiler, and I think they do the trick. So I need to know how they do it, but in theory, I think that should work. But I just don't know. But yeah, like if you know how it's done, like that can be a good first PR into the Python.
Yeah, let's see if it works. Gecko 6430.json. Let's see if it'll load from localhost.
Yeah.
It actually load. Did I just typo it? 64.
It did something, no?
It tried network error, but it actually made a request.
Huh.
Weird.
Yeah,
Oh,
you can see it there.
cross origin blocked.
It's like CORS.
Oh, CORS header.
Yeah.
Wait, is there a way to set CORS from here? Probably not, right? No.
There is a way, because I have seen it done, and I refuse to believe that Sampley embeds the Firefox profiler. Maybe it does, because it's done by the Firefox profiler guy.
Yeah.
So maybe it does, but like I don't know. We will discover. But there's a link. I mean, it's not horrible. It's not horrible.
Yeah, I think
Okay,
that would work.
cool.
Like run a custom HP server. It did hit localhost, so it sort of worked. We just need the core setters. All right, what are we doing
Let's
next?
do something. Yes. So grab from like I don't know the internet some stupid script that does some math. So like let's look in Rosetta Stone or whatever, some bullshit like Mendelbrot or whatever it is, right?
Okay. I mean, I could use some of my like advent of code.
That works. Yeah. Let's do that. That's even better.
I have a particularly slow day that is this the right one? Let's see.
Ideally, something that runs in like 10 seconds or whatever. Yeah. So I mean, we can delimit it by -d something. But oh, wow.
It's this day. Hold on. One of these is a linear algebra solver. Yeah, it's this one. Okay. This is going to be our sample here.
Yeah. Let's run that one. So run that under the profiler. Same options. Remove the -d. Well, how long does it take to run this thing normally?
It's not that long.
Well, we can add a -d fab just in case. So pass to the profiler dash gecko. Right. Yeah, maybe 5 seconds is fine. So pass dash gecko and then dash opcodes.
Opcodes.
Yes.
And
then just and then your thing.
Yeah, that should work.
And then upload the file.
Oops. Okay.
Then go to market chart.
Ooh. So now it tells me every Python opcode that's running.
Yes. So you can know, like what the hell your program is more heavy on. It kind of collapses them. So, in theory, the opcodes will be like a single point. But if there is like a lot of them together, it just collapses them because otherwise the Firefox profile will die.
Yeah, it'd be a million little
yes.
tiny slices. This is actually really
Yeah.
cool.
So this is very cool because you can see it on time, and then you can use the Firefox profiler to select an area, and you can correlate what the hell was doing there. But another cool visualization that you can do is that if instead of passing /gecko, you pass /heat map to the profiler.
Do that.
That will give you a folder, I think.
Yeah.
So open the index, that thing. Yeah.
Ooh, the animation. What does error rate mean?
Error rate means that the profiler tried to sample and then it found garbage.
Ah, okay.
Yeah, so that's because probably we're sampling either too slow or too fast. We will see. So go to part 2, click part 2 in project files. So this is like a different thing. This is just like a coverage kind of thing. So you can see here what's slow, but you can see that there's little arrow on the left. That's because we pass that's the opcode. So go high and then click one that has a bunch of complicated things and click the arrow, like the little arrow on the left.
Oh,
line.
This one to expand it.
Yeah, close to the lines, close to where the numbers are in the left. You see that little arrow? So click there. Wow. So you can see the opcodes in that line, and then it tells you, relatively speaking, like what opcode it is. And if you hover, you can see, I mean, here is red on red, so it's maybe not the highest, but if you hover, it kind of highlights in the line.
Oh, let's pick an orange one so it's not red.
Yeah, where that opcode it is.
Oh.
And also it tells you if the opcode is specialized. So it will tell you if the interpreter has been able to specialize. So for instance, in that one, it has specialized a normal call to call by exact args, which is as you know, a specialized version of the opcode. Something that you can do, which is very funky. If you go to the top of the file, there is this. So there is a bunch of toggles that you can use. One of them I think is called self-time. So self-time changes the colors based on total or self. But if you click specialization, then if you go down, I think go to the last one on the left. I think it says specialization.
Yeah.
So you can see now the areas of the code that are more specialized. The harder the shade it is, the more specialized that area of the code it is, because the interpreter has been able to reason about it more. There is something very funky that you can do. So you go high again. There is this option that we added, which I don't know if it will make sense. I think it breaks some people's mind, which is, I think it's hit only or hot only. So that removes every line that was not hit. So your code means nothing anymore. Yeah, so it means nothing anymore. But you can see it kind of preserves the line. So, it's a bit funky, but like now you can see basically all the lines that make sense. The line numbers are kind of like the original ones, but of course you cannot read it now top to right, but you can see like whatever. Like if you have a very long file and you want to see what the fuck is going on, like it's a very easy one. And here you can see like very easily what parts of the code the interpreter has been able to specialize more. This is also very useful because if you, for instance, see line 166, when you assign to mute IJ. So there is a bunch of shit going on in that line. But if you open the little arrow to show the opcodes, you will see exactly what is really slow in that line, which is the load fast. Because there is a fuck ton of shit going on in that line, but like it's just one of the operations there that is actually doing something. Of course, you could imagine a line that has like 2 function calls and only one of them is slow or whatever it is. So the advantage of the opcode view is that you can kind of like drill down in the same line what is expensive in that line. So if you have imagine you're adding NumPy arrays or whatever it is, so maybe it's just like one of those operations. Or imagine that you have pandas data frames and it's just one of the pandas operations that is really slow, but you just add 6 of them together. So a normal profiler will just tell you the line.
This line is slow, but you can actually drill further down it. That's huge.
Yeah.
Wait, I've already seen so much stuff that's just like blowing my mind, and like I could have solved like the number of times where I've had one slow line and I'm like, there's 5 operations here. Which part of it is slow? And so I'm like reassigning parts of it just to like tease it out of the profiler, but we can just get it directly.
Yes, it's very cool. It's very cool. Okay, so now I want to do another one together. So if you go to the what's new of Python 3.14, there is an example for the async.io introspection thing that we presented in the what's new. So just copy that code. It's like some sleep token references, I think.
This one?
So it's like a bunch of tasks and shit. So this is just so it gives us a bunch of stuff there. Yeah. So we just copy that. All right. And then let's so put it down your file. So instead of like sleeping there, because I think it sleeps for 5 seconds, we can do some. Well, no, let's do the sleep. The sleep is fine. So sleep is fine. Yeah. Okay. Cool. So now, So let's do something. Well, how we can? Okay. Yeah. So run the profiler on it with dash flame graph. Just dash flame graph and the name of the file. You can and no gecko and no d3.
Probably don't need all threads anymore.
Yeah. Exactly. Okay, so what you are going to see right now is what you will see in any other profiler. Like, doesn't matter which one it is, PySpy, Austin, C profile, whatever. Which is that it's a flame graph that mostly sucks, and you will see why it sucks. Because oh no, is the even loop? Oh no, most of your fucking time is the even loop. Of course it is.
Of course
because,
it is.
Yes, bullshit. It's not useful. It's not useful. Okay.
Agree.
But now you can pass to your invocation dash async aware.
Okay, so we're gonna actually get useful profiles from async.io.
Wow.
Oh, it didn't find any functions though. Do we need to do
Pass
something?
Do -h. That's kind of fun. Because all of them are sleeping, so there's nothing running. So let's do something else. Change the sleeping to... Well, let's do something else. Instead of... so if you go up, there is a section for async mode in the help.
Yep.
Yeah. Let's do with the sleep for now. So there is a section that says async mode. Mm-hmm. Yeah, so instead of running, do async mode all. So the reason that we are doing this right now is because all tasks are sleeping, so technically no task is actually doing anything. So with async mode all is just sampling all tasks regardless if they are sleeping or doing something useful.
That makes sense.
Hopefully that actually does the thing. We can run some async.io real code in a second. Okay, so now we have a flame graph, which is going to hopefully not suck.
Nice. Yeah, so you can see the 4 tasks.
And now you can see your task over there and like, how much time. Okay, so this is very important. There is something to do here. So async mode all tells you basically all the tasks that your even loop has a schedule. So this means, for instance, that if one of your, which is interesting, right? Like, for instance, when this will be interesting, maybe, I'm not going to make you code this, but like you can imagine that you have a async.io application that is downloading 10 files, but one of them is a terabyte or whatever. So most of the time is going to be waiting for the network to give data. So it's going to be just doing there. Meanwhile, the rest of the email loop will be doing shit. So if you profile just the running task, you're going to see that most of the time your program is downloading that data.
Right.
Meanwhile, something else happens. Or you can imagine something else. Imagine that you are looking at your program and then you say, why my program is slow? What can happen, for instance, imagine that the server that is giving you the data is so fucking slow that it's sending you the data super slow. So it's not that your program is doing a lot of shit. It's just like your email loop is just chilling out. Right. But if you do all, then it will tell you like that task is constantly waiting. So the more it's waiting, the bigger it will appear. So like that, you know that task is of course not doing anything, but it's just there. So you are waiting for a lot to happen. But of course you can say, well, sure. So you go back again to the code. Let's tweak it slightly. So if we go there, let's do something. Let's say, let's add a conditional to the code such that if the track is, I don't know, levitate or whatever it is, it's going to do some math. Yeah, so do levitate, let's do some math and then let's do await async.io sleep 0, so it just yields a bit the even loop.
I don't know, something that...
yeah, plus equal 1 is fine.
Yeah, okay.
And then do a async.io sleep 0, so it just yields between iterations of the... No. Well, wait. That will be for all tasks. That will affect all tasks. So we want all tasks to sleep. but we want that task to kind of like yield a bit meanwhile is doing the calculation, so it just doesn't like clover even loop. All right, yeah. Okay, so you, yeah, perfect. So you run the same thing, but instead of like with does the async mode all, you remove that part, it will run with the default, which is running. So in theory, we should see in the flame graph only one task now, which will be
that slow
will be the
levitate
task that
one.
is doing. Yeah, we'll see. Hopefully.
Maybe we bump up the iterations because it didn't find anything this time.
Can you print something on? Can you print the iteration or something like that?
Yeah, I can do that. Although it looks like bumping it up found something, so maybe that is good enough already.
Oh, okay. Now it's fine. Okay, just open that. Yeah, maybe it was just too fast. Oh yeah, maybe it's just too fast and it just sleeps for the rest. Okay, yeah, but you can see that now, there is an even loop there, but like most of that is in the handle of it. Yeah.
Let's print.
Cool. Okay, yeah. So all right, so the idea is that this mode will show you like the running one. Something else that we can do as well is like we can call sleep, just normal sleep, that will simulate that it's just doing something. Just sleep for 10 seconds or whatever, or 5 seconds.
We'll just put 2.
Yep. Yeah, and then you can remove the math if you want. Or yeah. All right.
Well, I left the math.
So, well, it's fine. The math will do the mathing. All right. So hopefully this gives us some samples. It should be overwhelmingly on that line. Let's see. All right. Yeah. Cool. So if you hover, it will show you the sleep.
Did I not get the right?
No, that's the even loop. But go click root.
Oh, here it is. This is the sleep.
Oh, right? Yeah. That's the bigger one. So it's 97% of the time is there, which is the sleep. Which it's like line 12 of the file. If you hover, it will show you the source.
Yep.
I'm looking the stream a bit late.
A little bit delayed, but yes, it's there.
Yeah. Yep. Yeah. Okay. So you see, like the idea here is that with async aware, you can sample async IO and make sense of the async IO. Of course, you need to tell that you want that, because otherwise it cannot automatically detect that you have async IO and say, oh, you want this. And of course, as you can imagine, that it's slightly slower because it needs to like sample a bunch of shit.
Yeah.
And also there is a bunch of decisions there that doesn't really matter, because you are going to get the answer you want all the time. But you can imagine that technically speaking, a coroutine can be awaited by many parents, so at the same time. So in theory, it's a graph. In theory, you can have cycles, and I think I use explodes, you have cycles, so nobody's had cycles, but in theory, it's a DAG. And the flame graph is not really friendly to show DAGs. So we explore a bunch of solutions here. We explore, for instance, if that happens, kind of like but the problem is that like we cannot easily assign weights to every parent, and it just becomes super complicated. So what happens now is that if you have such a situation where your task is awaited by 2 different parents with different roots, it picks the first one and it tells you with more parents. Like
makes sense. Yeah,
more parents, but it doesn't matter, because at the end you just want to know that particular task is just like doing stuff, and like it doesn't matter that 3 guys are waiting for it, because you just want to know which one it is. Like so in theory there is like in the high like high area of like the ideas, there is some visualization in 3D when like you could see the thing, but like
3D profiler, that would be wild.
Yes, 3D profiler. Yeah, that's kind of like insane. Cool.
I feel like flame graphs are hard enough for a lot of people to read. I couldn't imagine what a 3D flame graph.
We play with a lot of stuff. We play with like colors and like maybe like showing like you could switch between the alternative flame graphs when you could see different parents, but you can imagine that the like combinatorial explosion of that is insane, because you want the first one. And that's kind of like,
I think the thing that I look at, or I've been looking at the most is, I mean, this is gonna take forever to I think the profiling that I actually look at the most is dot graphs rather than flame graphs, just because that's what I started with.
Yes, and I know it, and I actually try to make that compatible. So the way you can use your normal workflow with that is that if you run so cprofile produces the pstats file, and then when you do the dot graph, I think you run dot to prof to dot or something like that, or I don't know what it was, but
is
there's
there a
a step that
pstats?
converts.
There's a pstats
Yeah,
output?
so you can run pstats. So pstats, yes, it's pstats. That's the
Oh.
default actually. So that's pstats is the first one in upload options. So yeah, but you need to, so pstats throws to the standard output. So you need to give it a -0. Yeah, there you go. So that will show pstats. So you run that. In theory, over the file, you should be able to run the prof to dot thing, and it should just work out of the box.
I didn't install it, did I? I'm using a fork of. Oh, I have it installed. I guess it's, yeah. Oops, and then pipe it to dot. Could not load. What? Oh, I gotta open it with Firefox. Otherwise, it's trying to do. Wait, why did I end up?
Oh, okay, that's kind of funky, huh?
I think I just used
Maybe
the
it's slightly
wrong.
different, or okay.
I just don't remember the command. Hold on. Let me look at the code samples from my YouTube videos and figure out what command I'm supposed to run.
I mean, maybe that is something slightly different in the pstats file. I hope not. I think it's like mostly it tries to really hard using the same technology.
I forgot the TSVG part.
Oh, the magic.
Fortunately,
okay, the format.
past me knows what's up. Yeah, here we go. This is what I feel like I usually end up looking at. Cool. So I can still use my.
Okay. Wow, it worked. Amazing.
My same workflow.
Cool.
Nice.
So you can preserve your cool thing. All right.
Also,
let's do
thanks
something.
past me.
let's do something cool. So your editor is Python, no?
Yes, it is entirely
Can
written
you run
in
it
Python.
under? Can you run it under 315? Is that something that you can do?
Yes.
Can you try to do that? Just open your editor under 315.
Let me get a virtualenv and install it. I have to build CFFI first. Hold on.
Oh wow!
Okay.
So very advanced editor.
Unfortunately, the only reason it needs CFFI is because the regex engine that VS Code uses for its themes depends on this particular regex library, and I re-implemented I re-implemented the TextMate grammar highlighter in Python, just to make that perk work.
Nice. All right, let's start your thing.
Hold on. I'm using a deprecated thing that got removed.
Oh no. Sorry, parse. What the hell is that? Did we remove that?
AWC Bongo, AWC Bongo, AWC Bongo.
I just received a notification that Mark Shannon joined Telegram.
Apparently,
at this very moment.
From RE import parser.
Ooh, dirty underscore parser, man. Come on.
So annoyingly, I only need to validate that a regex is correct, or a replacement string is correct.
The weakness of my flesh, it disgusted me.
There isn't an API
I
for it.
crave the strength and certainty of steel.
It's running.
I aspired to the purity of
with
the
a terrible
machine.
patch.
Is right?
Your kind cling to your
Is
flesh,
this the editor?
as though it will not decay and fail you.
Okay, so go to the other window and get the PID of your
and you
thing.
will beg my kind to save you. But I am already saved, for the machine is immortal.
With editor running, yeah. So we have the PID, and then we're going to run the profiler, and then instead of run, I think it's attach. But then we're going to pass attach the PID, and it's the same options. So the PID, and then does live.
Ooh.
Live. No, don't put the flank graph. Just do does live. Yeah, and then enter.
Okay, cool. The error message. I need to...
this is the because it's trying to attach and it needs ptrace, so sudo. Just run under sudo, or you can deactivate ptrace permissions using that echo command.
This error message is really helpful because I every time I go through a profiler, I'm always trying to find this particular command, and my password is bad password, by the way, so that's why I'm okay typing downstream.
All right, because you have like like a camera pointing to the keyboard or something.
yeah. Usually your face
Cool.
is covering the keyboard camera right now, but usually
Oh, okay. I'm saving the passwords. Okay, so now you interact with your editor or whatever, you can see live what the hell is going on.
Oh, that's really cool. Let's see. Let's open another file.
Something like crazy or whatever.
What can I pick here? Let me find the largest file in CPython.
Socket.py or test socket, I think. So lib test socket. No, it's lib test socket. I think that's the largest file in CPython. In Python.
Oh, wait, I have the
If
wrong.
you care about C, we can open parser.parse.c, and that's fucking ginormous.
Oh, we can do that one too. Lib test socket.
Yeah.
It's actually really awkward to open a file if you don't already have it open. Okay, so the first part of this file is not going to do much, but the worst thing that you can do in my text editor is jump to the end of the file because it has to highlight the whole thing at once. And so you can see while it ran.
Wow, look, a bunch of shit happened.
Yeah.
Okay. So of course this is just to show you live mode, but you could pass the flame graph and a bunch of like time or whatever, and then it will sample your process like if it's running it. So you can use that as a flame graph, you can use that as a gecko, you can do whatever you want, and you can also control C the program and it will stop sampling at that point. So or you can like do -d 10 and sample for 10 seconds. The kind of like cool mode here is just like to show you the trader screen, and then if you press H.
Is there a way for it to ignore a particular function call? Because like I know it's almost always going to be waiting on input, which is what it's sort of doing right now. Like this particular function.
You can yes you can something else. So quit that. So Q. So that is a perfect segue to the new cool thing that you can do. So okay, so do the same thing, but instead of /live, do --mode CPU. So sorry, in addition to /live, do --mode CPU. So that will ignore any single frame that captures when your thread is chilling out. So now you're only seeing frames that do CPU bound tasks. So if you do the thing that we did before with a different file, so open, for instance, parser.parse.c, which your editor is going to choke, I'm pretty sure.
Okay, parser.c
or something like that, I think it's called.
Let's see.
Parser.c. Yep. This is my baby. It's humongous.
Why did I not get the right one?
Yeah.
I'll just copy paste this that way. So I don't know why it didn't open it. Oh, there we go. Okay, so if we do the same thing where we jump to the end of this file. Oh, it's so slow.
Yes. Yeah, indeed. Okay, but you can see
but
now.
It did eventually do it.
But you can see that it's running the GC a fucking ton of times and a bunch of other shit. So this is very cool because so we don't have a way to ignore a function right now. You can search. You press help or H in the live thing. You can see like what you can do and things like that. But this was the perfect example for the CPU, because you can ignore all the IO bound like nonsense. By default, it's wall time, but you can do CPU only, so you can focus only on the functions that are like just hammering your CPU. And then there is also that mode GIL, so you can only select the functions that are running with the GIL, which is not the same. Because, like, you can imagine, like, yeah. And then there is a secret one that I will not reveal live.
Okay, all right. I'll have to find it out.
Yes. I can tell you what it does. It's one that is called mode all, and what it does is that it does secretly is the one that activates when you do gecko. So what it does is that it doesn't filter anything, but it marks the frames with whatever they were doing. So that's the way the gecko mode knows if it's in the GIL or in the GC or like blah blah blah. It's just like it's more expensive. Yep.
So wait, there's a Levenstein distance in Python? What is this?
Oh yeah, I coded that. Yeah, I call it the thing. It's not, I don't know why it says JSON, but there is a Livingston distance. There is two actually. There is one in suggestions.c, which is the secret Livingston distance bullshit that we use. It's a slightly optimized one that we got inspired from the algorithm in GCC, the one that GCC uses to do the did you mean. So that's the one that I coded for all the did you mean bullshit.
There's a secret suggestions module now.
Yes, it's exposed in traceback.py. You want to use that. So yes. So that is picking the Livingston distance from somewhere else. I don't know where we put it now. And I think there is another one that is pure Python in traceback.py. But you check for suggestions to see, that compute suggestion error I think is called. But that's the secret Livingston distance mega thing. But you can do mostly with difflib. I think difflib has some more sophisticated did you mean kind of implementation.
Nice. I was just trying to find a large file in Python again to do editing
I think
things.
the parser is probably the one that is going to kill you the most. Isn't it like a famous command line thing that tells you like the biggest files or whatever?
Yeah.
Some Japanese name.
There's I know what you're talking about.
Oh, okay. So text socket used to be the bigger one, but now we have test typing. Of course,
typing is winning.
of course. It cannot be any other way. So test typing. Let's see what happens.
Did I not do this correctly? I really should be in the right directory, but I'm not. So we're using absolute paths.
Oh, it's because you need to read link it. Yeah.
Okay. So this is the GIL mode. Yeah.
So it's going to be very similar to CPU mode because you're not doing anything funky with C extensions when you drop it, but it's slightly different because CPU mode will include functions that are just calling C code with the GIL held. So without the GIL held, I don't think you will be calling any, but like it could.
Well, actually, no, I am calling some. So like the difference here, this expand escaped is implemented in purelib, but this reg set calls down to a C extension, and so I think CFFI drops the GIL during that, and so it sort of makes sense.
If they do that, then you will not see it. But yeah, that's mostly it. And then of course the kind of counters will not show you GIL or not GIL because like it's just filtering for GIL, so it won't tell you GIL percentage, but you can see 0% GC, 0% exceptions. Cool.
Very cool.
So that's very cool. So another thing that I wanted to show you is okay. So if you do your example for the math thing that you did in the Advent code is really good. So let's do the flame graph again for that one. But just run it. Don't open it. Do -m, that's flame graph, and then the name of the Advent code thing.
Part2.py. Yeah.
Okay.
Well, I got it. wrong Python. Only activate the right virtualenv. And I forgot run. And it will take a little bit of time. I should have done the -g. Well,
no, that's fine. Let's see. I'm looking at the stream, so sorry if I'm like 2 seconds below. But yeah, you see, okay. So there is a bunch of interesting things. Here we can see that the error rate is really high. It is 57.56%. So this is a very good segue to talk about. So that's kind of fine. That means that it made like a lot of samples when like it found garbage. So the reason it found garbage is because by default, Tachyon tries to run in such a way that it will not do anything to the application that is being observed. So it will not stop it. It will not do anything. It's just copying super fast from the process. So by default, it does this as I think 1000 hertz. But Tachyon can do so much faster. So if you do, so you rerun the thing, but you do -r 1000 kilohertz. So you can run -r and then 1000 khz, like the unit. I think that should work.
Looks
okay,
like
so now
it's
running at like a much faster rate. So it's sampling much more. Therefore, it's going to generate a ton of extra data. The thing is that you still have 56% of error rate, but you have many more samples. So you compare that to
Way
the previous
more.
output. Yes. So that means that sure, like half of it are still bad. In a second, I will tell you why. But like now you have like much more samples, and if your functions are running like for a super small amount of time, you can catch functions that are much faster.
Right.
So for instance, if you have a function that is just doing something very quickly, ramping up the sample rate, it can catch something else. Cool. So why still 56? So by
Can I
default,
guess?
yeah, by
Is it?
default, it will not try to stop your application. The reason is because I want Tachyon to by default do the less invasive thing, even if it needs to reject samples. Also, Tachyon does something that no other profiler does, which annoys a lot of people in other profilers, which is that unfortunately, when you are sampling, the interpreter is moving, right? So your profiler and the interpreter are basically racing.
Yeah.
Normally, if your profiler moves faster, in theory, this is very simple. If the mental image is like you have someone like a vehicle that is moving, and then you're taking photos of the vehicle.
Yeah.
If you're taking photos very fast, you can see like the vehicle without a lot of blur. But of course, if you take photos that takes like longer exposure rates, then you will see some blur there. So this is more or less what we are seeing here. The problem is that the interpreter, when it returns from functions, sometimes it unlinks frames. So like, it goes to the previous frame and unlinks them because it's a linked list.
Yep.
So what can happen is that you are sampling in such a rate. It can be both ways. So it can happen if you're fast and slow, but it can happen is that it's sampling in such a rate that you are sampling the frame that is being unlinked. So you will see that your frame is nothing. So unfortunately, and this is very interesting. So unfortunately, the way you finish all the frames is because the parent frame is nothing, is null. Right. So most profilers will confuse this situation when I finish sampling. So it will show you like a simple like a leaf function. So I don't know, sleep or whatever, as if it's the only function in your program.
Right, as if
because
it's the
there is
root
no
node.
way to distinguish those situations exactly. But Tachyon, what I did in Tachyon is that I added a secret frame that is at the top of the linked list that is a sentinel. And then Tachyon, if Tachyon doesn't find the sentinel when it's unwinding, it throws away the sample and tells you like, okay, I have some data, but it's garbage. So
Makes
like,
sense.
because I couldn't raise the interpreter to do that. So most of, if not all of those 56% shit that throw out is because it's finding this thing. Something that you can do to find it, sometimes it's impossible, it's just because the interpreter is just moving too fast. But something that you can do is that you can pass, that's blocking. So blocking is a bit more aggressive, but what it will do is that the Tachyon will stop your application, take a photo, and then restart it. So if you remove the -r, because with that high rate, we show you a big warning that
the warning is very helpful.
Yes. So we can talk into that about that because that's very interesting. So okay, so that thing it will take those photos, and then it's not letting the interpreter do anything until it finishes the sampling. Hopefully that, yes, you see the error rate now is like almost nothing.
A lot lower, yeah. But not
because,
zero.
Because it's not zero because you can still stop the interpreter when it's like doing something weird. And it, like, for instance, it's like linking the frame, or it's just doing like exceptions, or it's doing something like when Tachyon cannot make sense of what the fuck is happening. So, but it's just like because that can only happen at the time you stop, but before it could happen at any time as you unwind. The error rate went much lower. Of course, the downside, as you can imagine, is that we can check this. So run this with and without blocking, and just put time in front, so we can see how much time is taking.
Yeah, so fortunately my script already prints it out, so we can already see that it normally took.
Perfect. We have 8,000 milliseconds, and the other one with no blocking,
it was like 7,800.
Right. Yeah, so you can see that it's slightly slower, because of course what's happening is that it's stopping the application, is like sampling very fast, but like that accumulates for a long time. Of course, if we run with it's like what, like 5% or 6%?
Yeah,
Or
somewhere around there.
Yeah, so if you run with now a higher sampling rate, so let's do the same and then put back the -r, which we will show you the warning as we saw before. It's just like, I think you can, like a -r 1000 kilohertz.
Okay,
Okay. Let's go one. Yeah. So here, I think it will show you a warning. Yes, it tells you like this is a bad idea probably. The reason is because Tachyon is stopping your application so many times that your application has no time to do anything. So it's going to take fucking forever because like share is sampling a lot, but your application is not moving. The reason is because the stopping in Linux it works with signals. So it's like sending the signal, stopping the signal. So you see that your program is like now running to a crawl because like it's just not being able to do anything. Of course, we added this nice warning to tell you like this is stupid, don't do this. But
you idiot, why did you do
you
this?
exactly. You can imagine that there is a graph that will show you that if you plot basically the impact on your application and the sampling rate, you will see that until the default sampling rate or around it, the impact is almost zero. So even if you use that as blocking. So of course it's slightly more, but because like the blocking thing is happening, but like almost nothing. But from 1 kilohertz to 1 megahertz, like you're stopping like let's say the time of signal delivery and reaction is comparable with the sampling rate. So then the percentage of slowdown goes high until I think with 1 megahertz it's almost like 90%, or as you can see it's like a huge amount, right?
Yeah, even at 10 kilohertz it's struggling to start.
Exactly. So that's why we kind of recommend to, if you use this blocking, do the default rate or a bit less even. Of course, the advantage here of that blocking is that the photo is just a photo, right? So you have no blurring. Because something else that can happen, and stacking is also subjective to this, of course, is that you can imagine, for instance, that you have a function, the function calls something else, it returns and the parent moves. So like imagine that you call foo and then bar. So you go into foo, you return from foo, and then you move to bar. So what can happen is that you sample at the time is in foo, you unwind the stack, but before you actually took the second photo, you sampled the parent frame moved to bar. So from the point of the sample, it looks like bar, like bar called foo.
Yeah,
so yeah, that's called smearing. So that's because like it's like blurring, like because as you were taking your photo, your program move.
Yeah.
So it's like you take a photo of the child, you go to the parent, but before you could take a photo of the parent move. So then it looks like that. Of course, that happens really, really rarely, but it can happen. With that's blocking, that thing is eliminated. But of course, now you're paying a bit more.
Right.
PySpy defaults to that's blocking. Which is a choice. I think is the wrong choice.
I kind of agree because it adds impact to running profiler. But.
Well, but on the other hand, I'm pretty sure that the people that, just to add devil's advocate here, some people will tell you that profilers will tell you like very high quality data, so you shouldn't lie about what you see. But like you're going to make sense of what you see, right? And if you see 63% of failed samples, you know that like that data is missing something. Or if you see that there is a function that doesn't make sense, if you go to the docs tell you like, oh, you can run in that's blocking and see what happens. Of course you may need to, so just to be clear, the default sample rate is 1 kilohertz. That's already too high. Like that's a fuck ton of samples per second, especially for Python. Like for instance, perf will start to complain if you go even at 1 kilohertz. It will tell you like, no fucking way, you need to activate extra options because it samples too much. So you can sample very easily at lower rates, and that's fine. Like it's not that you're going to miss anything. We are even like thinking about like going a bit down, but in theory, Tachyon is capable to sample at a stupid amount of frequency. Like in my machine, it can reach 1 microsecond, which is 1 megahertz, with a very shallow frames. So I think like 50 frames or something like that. Of course, it depends on your machine. It depends on your hard drive. It depends on like a bunch of shit. Okay. There is no, the interesting part, and this is very cool, there is not zero impact, even if you don't pass that's blocking. But that only happens when you sample at ridiculous rates, like 1 megahertz, for instance. The reason is the following, and this is so cool because
CPU sharing
I hypothesize. No, you will see it's much harder.
Okay,
like I saw this because I was plotting it, and and then it's like zero impact, which is what you expect, and then around 1 megahertz, it just goes slightly higher, not to anything crazy, but slightly like to 3, 4, 5%. And I was like, what? Because like it's not stopping it. Like why is making it slow? The reason it's making it slow is because when you read from another process memory, the kernel needs to flash the pages. because if
Oh.
the data is in the CPU cache, then it needs to tell the program, hey dude, like put the data back into main memory because I need to read it. Technically that doesn't need to happen that way, because the kernel could like read from like the L1 or whatever, the L2 or whatever it is. So depending on your CPU, it will put it somewhere else, but not in your CPU cache. So if the data is in your CPU cache, it can like it needs to flash it, and you will see that you profile with perf,
So you get like a page fault.
kernel pointers activated. You will see not a page fault, but I think it's a function in the kernel called like sync map, sync map something. And that thing, what it's doing is that it's just ensuring that the view of the memory maps that it's sampling from is up to date. And that normally is so fucking fast that doesn't matter. But like when you're sampling at fucking 1 megahertz, the kernel is like, holy shit, I cannot keep up, and then it needs to stop the application. There is a lock, and then it preempts the application, and then it just reads from it, and it gives you the data. So at 1 megahertz, there is slight impact on the runtime of the application because the kernel cannot keep up with the fucking thing. And
That's
it needs
awesome.
to yeah. So nobody should sample at 1 fucking megahertz. Just to be clear, that's a vanity metric. So it's just to so that we are really fast. And also, like 1 megahertz is normally unachievable. Even like it's just vacuum, like spherical cow in the vacuum and whatnot. But
the spherical point mass cow,
exactly. So, but in theory, it could be achieved, right? Of course, like by the way, just to be absolutely clear. So Tachyon is also slightly in a bad position. The reason it's in a bad position is because in the standard library, and all these like tooling that you are seeing, all these flame graphs and like the outputs, they are written in Python. The profiler of course is C, but the data is like the thing like reading the data is Python. So unfortunately, even if Tachyon can sample at a stupid fucking rate, the code to kind of like make sense of the data needs to be Python, because that's the deal. So any profiler like PySpy or Austin, for instance, I expect them to be slightly faster when they adopt these techniques, because they don't need to produce tuples and shit.
They can write Rust.
Although we are but I think we are even in the same realm, because like even 1 megahertz is more or less, I think, like what these profilers should be able to achieve max rate. So not too bad. Of course, like we will see what happens, but that is not that you should use the tool that you like. It's not that we are competing. Like at the end, the idea is that or the idea that I have with Tachyon is not to just like remove these tools, is that they will have a easier time to port. So like the whole ecosystem, the whole profiler ecosystem is more healthy, and there is a representative implementation of how a profiler will look like, so such that when we upgrade Python, we don't break shit. For instance, the JIT compiler could break all profilers all the time, because like the JIT compiler can like do a bunch of shit while like profilers cannot sample. So now that there is a profiler in the standard library, every profiler knows that either is not broken or what they need to do to not be broken.
I mean, for me, it seems really powerful to have, batteries included, Python's batteries included. Right. Like it's nice to have something that you can rely on that will hopefully always work and like consistently be there. Like in the same way that I mean, I run into this all the time with like linters and code formatters with the AST module and the tokenized module, and what used to be lib2 to 3, and it was always just that like, oh well, there's 2 tokenizers in Python. There were 3 AST implementations at some point.
With 4 parsers, I think, at some point.
4 like and it was always like pick the one that keeps up with the actual way that things are done. And I'm sure better than other people that like tokenize was wrong for forever because it wasn't the real tokenizer. And so like
not only that, like the tokenizer was it's a bit amazing that existed, even because for a long time the tokenizer in Python was basically implemented with regular expressions, and in theory you cannot implement the tokenizer with regular expressions because the indentation is the indentation is braces, basically.
Right.
And you cannot parse recursive structures with the regular expression. So of course with the tokenizer, this is like it hide the fact that it was a parser by nesting regular expressions. So of course, like yes, you could do that. It's called push down automaton. But like when in parser theory, when you talk about push down automatons, those are the toy parsers. That's like the nobody does this. Which, by the way, just to be absolutely clear on this, before we did the peg parser, the real parser was a push down automaton. Because Okay, now draw your own conclusions here, but the reason is because it could be a push down automaton, even if it's parsing a real language. I mean, quote real language. Is that I mean,
Real.
of course, it's a real language, but I mean, my point is that, like, I'm pretty sure you can parse real languages with push down automaton is fine. I don't want to make fun of them, but it's because
But you also do.
Python was. Well, kind of like, but I'm live. I cannot tell you exactly what I think. but yeah. So it's because Python was LL1, kind of quote LL1, because not real LL1, as we very well know.
Right.
But because Python was LL1 for a long time, you could parse it with a table parser. The automaton can be done when you eliminate something called epsilon productions. So epsilon productions are productions in the grammar that give nothing. So for instance, you can imagine a rule that gives the input string. So you could, it's a rule that is always free to consume. So you can imagine that rule can be either A or B. So in theory, if A and B are tokens, either you consume A or you consume B. But like you cannot just do.
Can't consume
but like,
nothing.
If A is an you could jump over A. And that, as you can think about, like, even if LL1 means that you can only pick one token ahead, if one of those productions have nothing, then in theory you could jump over it. So you cannot just look at the tokens in the next rule, because technically that rule could be jumped across.
Right.
So that fucking thing complicates this entire ordeal. And then you need to introduce two things. They are called first sets and follow sets. So the first sets is the obvious question: what tokens this rule can start with. So for instance, if you see the rule for while, that rule needs to start with the keyword while.
Token,
like there's only one, but a statement can start with a bunch of them. But of course that's not enough if you have epsilon productions, because you could jump over one of these. So you need to introduce this concept of follow sets, which are like, if I jump over this rule, what is the token that I need to consume? That complicates the entire thing. So Guido said, what about if those don't exist? and then only then you can construct the parser with the push down automaton, which is what which was still sophisticated, because it did the non-deterministic automaton, and that, like, simplified to deterministic one, and, like, trim the thing. So it was not stupid. It's just like, in the world of parsers, that's like normally one of the simplest one that is non-trivial. So the tokenizer was doing kind of like that, but with regular expressions.
Faking it.
We try to. Yeah, as you very well know, because you suffer the consequences of our actions in the
over and
312,
over. Yeah,
it was 312. Yeah, sorry about that.
I mean, it was actually
312,
it was bad, but it was also really good, because it meant that every tool that I had built on top of the tokenizer just magically got 3 times faster.
Yeah, and also you got the f strings with, like, you could analyze f strings inside.
Yeah.
With the tool, which it was weird, because, like, man, we keep looking at all the tools you maintain to try not to break them, but it was kind of impossible. In particular, I think it was Flake 8. Yes, so that was really hard. I think we managed to do it, but I think the way we broke it was that something either in Flake 8 or something else, or one of the two, or maybe I'm
PyCode style.
No, it was PyCode style. Yes. So one of these tools have the fact that it uses this funky, because the API of the tokenizer is just bananas as well. Like the fact that you need to pass this, like, next function or whatever the fuck it is, like readline function.
Yeah.
So yes, so one of your tools have a class that basically implements an iterator that holds state, and then it just counts the lines. Yes, it kind of like counts the lines based on how many times have you called next.
Yep.
And then depending on where it is, it just does a bunch of shit. And the problem is that the way we did that is that we said, okay, in the new, because we are unifying the tokenizers with the real one, so we are using the real one tokenizer, we need to consume the entire stream, like, in one go, and then we will pretend that we didn't do that. So your tool broke. Because,
I remember
because the line was always the end line, like it was called, like, at the end of the string, where it was expecting that it was, like, the two things synchronized. So we switched to the readline implementation, even if it's a bit more difficult. This, like, now as you can see, there is this generate tokens things. There is another one called _ if you go to tokenize.py in the standard library, there's a secret function called generate tokens from C tokenizer.
Just make it the public API. The generate tokens shit
is
insane.
So if you go at the end, at the end of you see there's the or C tokenizer. Yeah, there you go. Generates tokens for C tokenizer. So that thing you can pass this extra tokens thing. So the extra tokens thing is basically the flag is do I pretend I'm the old tokenizer or not?
Oh.
So yes. Yeah,
Nice.
so if you pass extra tokens, it will send like all the comments and like NL and blah 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 blah. If you don't pass extra tokens, you can get exactly what the tokenizer sees when it passes Python, which was really useful for testing it. So if you go to the test tokenize, you will see that we use that to test what the tokenizer sees. You can of course say, how did you test the tokenizer before? And my answer is, haha, what tokenizer? So yeah, maybe we didn't test shit. But yeah, you need to. Oh wow.
Is this still a callable?
No, I think is the real line still, no? Or so what the fuck is source? Yeah, you need to do the IO string, blah 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 blah. Check how it's called. Bytes, read line, I think, no?
There we go.
No? Yep.
We got it.
All right, yeah. So you pass like extra tokens, you will see there's like a bunch of extra stuff. So you don't see the comments, and then there you will see the comments over there.
Wait. Yep. Oh, I passed it to the wrong thing. I'm dumb. That's my bad. Too many parentheses here.
Yep.
It's
a bit difficult to comment code in the future because I'm kind of I need to react to the thing. I'm thinking like what is the best way to do this, because I'm reacting to the stream in the future, but like at the time I see the thing, it's already on the screen. Yeah.
I think next time I'll share my screen that way. Although if I do it now, it's gonna fuck up the overlay. So
no, it's fine. But yeah, hopefully you see like the comments and whatnot.
Yeah, we got there. Took a bit.
Yeah, and it also does a bunch of things to no break your stuff. So I think it does. I don't remember what it is. I think the lines don't overlap or some shit, because the tokenizer couldn't give a shit if the lines overlap or not. So I think that they don't overlap. I think there was a bunch of funky, like an F string inside an F string, but with a formal specifier under the back. Blah, 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 blah. By the way, the F string, the back thing is the anti-Christ of the parsers, because you think about it. Yeah, think about it. If you think about it, when you tokenize the thing, and the parser just doesn't see the source, it sees tokens.
Right.
And then, but the back thing needs to remember the source. Like it must remember the source. But when the perk parser is parsing, it doesn't know if the tokens it's seeing are going to be actually useful for anything. So it needs to kind of keep them around. It's just so wild. Like it just needs to keep them around, puts them in a secret data structure, and like from the data structure, it just pulls them out, and like it does this garbage collection scene to the ones that have been seen. It's like so horrible, just because like you could do the back thing.
Awesome.
But yeah. Cool.
Okay, we've gotten a little off topic.
Just
which is great.
So now that you know the profiler thing, I think like one thing that could be cool is that you test it around, or you play a bit with it on your own time, and just tell us what you don't like, or any bugs or whatever. But like we still, there is a bunch of things that we are not super sure about. Of course, there is a bazillion options.
Yeah.
So that can be a bit overwhelming. So I don't know what's the best way to organize those options. There is something that we have not talked about, which I think is cool before we finish. So if you go to so let's run again your math thing.
Yep.
With so instead of flame graph or whatever we're using, pass that's binary, and then minus all, and give it a name like binary.bin or whatever it is. And then I think that is fine. I generate the one for you. So binary blah blah. Okay, so this is the other mode that it has. So the objective for Tachyon is that generating these files is like so obvious that like you just pass flame graph and then you go to flame graph and that's it. Like no more bullshit. But then the question is like, okay, but what if I want to like run my code once and then play with a bunch of options? I just don't want to keep running it. Or like, what if I want to send the profiler raw data to some other person? So these binary files, if you do the like check the size of the thing, so actually run the profiler again with that's binary and run it at 1 megahertz. So like just generate a fuck ton of data. Like
R1. Can I actually just put MHZ?
I don't know if we take 1 megahertz, but we can take 1000 kilohertz. Yep. It's like we don't want people to get excited with the megahertz, like 200,000.
Because they probably don't need it.
Yeah, it's advertisement, like marketing. It's like, wow. I mean, it's true marketing, but like, okay. So it looks like this. So we have like a fuck ton of samples, like 500,000 is that? Okay. So, but you see, like nothing, like just nothing.
Yeah.
This thing is like not only compressed, it's temporally compressed, is varying compressed, is zigzag int compressed. This is so fucking layers of compression and shit. And it just doesn't matter that your hard drive is low because it will just map, like it just do all the fucking tricks in the book. It's just ridiculous.
Yeah.
But now you can use Tachyon. So you provide a sampling, and I think it's replay.
Yeah.
So replay takes the same options as run, except that it doesn't take it just takes the file, and then you can generate basically a flame graph from it or anything that you want. And it will read from the file instead of taking the like a program to run. You need to pass the file, and it will show you even a progress bar because it knows how big is the file. So it will show you how many. It will explode all the samples because of course this is compressed. But like now it generates this flame graph, and now you can pass other kind of like formats, and it will generate all those formats for you if you want. So like
nice.
You can still kind of like generate like all sorts of different ones.
And we've got a nice little shout out from Emma with the Z standard compression here too.
Yes, although unfortunately I didn't use any of her code.
Oh no!
Because it's because we need to do it in stream mode. So this is not like we generate the file and then we compress it. The reason is that we don't want to take the uncompressed size, like in the sense that if you, let's say you need uncompressed 1 gigabyte, so that means that you will need at least that gigabyte, and then we will compress it to like whatever. But I don't want you to need 1 gigabyte. I want you to need always as maximum the compression size. So we leverage the fact that C standard is in the standard library now. So like we use the fact all the the configure and all the stuff, but like it doesn't use any of the compression library. It uses the piping API. So, and then there's a dictionary encoding because we know that there's going to be integers and the temporal blah blah blah. So probably can be optimized a bit. I mean, I dedicate like a couple of days while I was unemployed to I switched jobs very soon. So I had. Do
you want to talk more about your new job or is it?
Yeah. I work now at Hudson River Trading, as well as HRT, which is a very confusing name to say that you work at.
Right.
Yes. I think it was my brother. I said, I'm going to work at HRT. He's like, what? Like, do you mean with HRT? No. Well, I mean, yes, but like also at. Like, what do you mean at? But yeah, very cool. I mean, it's kind of refreshing to change jobs after like forever.
You were at Bloomberg for forever. Like
almost 10 years, I think. So yeah, Jesus Christ. So yeah, very cool. The how they call it, the kind of like water thing.
The fire hose.
Drinking from the fire hose. Drinking from the fire hose thing. So very cool, cool challenges and whatnot. So very, very, very happy with the move. But I was unemployed in December, and my productivity was over fucking 9,000. You can check it in GitHub. So I just implemented all the features of everything, and I implemented this C standard compression, I think, in 2 days. Actually, I think like if you check the 24th of December, I think I had like 73 comments or some shit.
Yeah. Oh, it's in my time zone, so 76. But productive December.
Yeah. Nice. All the features were implemented in December. At least 5,000 lines PRs were produced there. But yeah. Cool. So so the thing uses the C standard stuff, but not the real compression thing.
Nice. Yeah, this being able to replay
I have less time. Yeah.
Oh, sorry. Go ahead.
So this replay thing is just closing the stream. So the replay is very cool for the kind of like producing things, but also for sharing the data. So if you want to send the data, these files are so small. Like if I did the test. I think the data is on the PR when I introduced this, but I think I tested the entire test suite of CPython at 1 megahertz, which is not really 1 megahertz, is whatever the profiler can achieve close to that.
Yeah.
And I think the data is like 23 megs or something. It's fucking ridiculous.
That's awesome.
But if you think about it, it has a bunch of very smart stuff, because if you sample really fast, most of the samples will be the same because Python has not moved. It's just the same shit. It's doing the same things. Of course, maybe changing in C, but like whatever is doing above is the same. So you don't need to, like, you can basically do dictionary compression. Yeah. And then you say 23 of these, right? So you have these like buffer layers in which you say, okay, I'm buffering like the last 5 samples, and then you can refer to those. So you can, because you can think, okay, so the last one is going to repeat a bunch of times, but what if like that's enter exit, because that is also a missed opportunity, because you can say, enter exit 5 times, but even if you cannot detect the enter exit 5 times, you can say, 5 times the -2 sample. So it tries to be smart about it, and like try to find like runs of like stack frames and whatnot, and it has this trick when it can represent with an integer the entire stack trace. So it's very cool,
very complicated, very sophisticated.
End, of course. Yeah, if you go to actually it's very cool to do this in the stream. If you go to the sources of CPython, I added this file in internal docs, I think is the folder.
Oh. Yeah,
internal
I have
docs,
not seen this directory before.
Yeah, so use internal docs profile binary format.
Oh, cool. Is there a
so here
is there
here
a
explains
marker
all
yet? Because file gets real confused with it.
Yeah, I don't know.
It thinks it's a LiDAR ASCII form. No.
Is that what?
Whatever.
Bad metric LiDAR. Bad metric LiDAR. Okay, maybe I should put a marker or something here. I mean, it has a cookie that says like the version and whatnot, but like it doesn't say. I think XX tachyon or tachyon at the beginning, so maybe that's why it says LiDAR. In the header, that header that you see in the diagram, I think it says tachyon at the beginning. You do an extamp.
Yeah.
Just 10. Yeah.
Here we are.
Yeah.
TACH. Yeah.
So you can see like how like it has this string table. So it doesn't.
Is the endianness
it
correct?
Basically doesn't.
Because mine's showing HCAT.
I think so. It has to, because it's also agnostic of the endianness. Like it tells you which side it is. If you open the code to parse, you will see that it checks the endianness.
But the 4 bytes that I get at the front are HCAT.
Oh, the other way. Oh, I see. But I think it's because I fixed the size. Side. So it's always like little endian, no? So it's always little endian, even for the entire stream. So if you open the, I think this is in modules, remote debugging. So you go to modules, remote debugging. I think it's binary something. You will need to autocomplete there.
.c or the header? Or?
Yeah, it's C code, and then it's binary IO writer. Yes. Or reader, because the reader needs to know about the endianness. So I think there you will see reader. So if you go down, you will see. No, it's one of these macros. It's pi. Yeah, there you go. So it checks the pi bswap 32. So that thing is what switches depending on the endianness. So it detects the endianness of your machine and switches depending on it, because it's recording the integers raw. I mean, it's doing binary compression, but like it needs to reconstruct them in the proper endianness. So it has a bunch of tricks to work across endianness. Of course, like I hope nobody sends a profile from a HP machine to like whatever, but
Yeah.
But in theory you can. In theory you can. Like it does things correctly.
Yeah, interesting.
Um,
So, I
Yep.
mean, I am seeing the bytes in the opposite order on my machine.
I mean, as long as it works, it works.
It works. It works. Yeah.
I think if you go to writer, you go to the writer. I think it's just like a C string that gets dumped in the proper order. It has to be.
Yeah. Let's see.
Yeah. You're seeing it. The binary format magic. Yeah. It just flipped, no? Or maybe I
Yeah.
just did flip.
Yeah. That's
Well,
backwards.
whoopsie.
Anyway, easy fix, right?
Yeah. So
We-
or rather, yeah, it's duck. All right. Well, now you know it's an Easter egg. Now only the people that watch Anthony know that Pablo fuck up the order.
we'll know that we have the backwards endianness at the start of the file.
Whoops. Maybe don't use Python to get the X code of your strings. Maybe don't.
Well,
do
no,
that.
this constant's correct because let's see, OX. Ugh. Like this is correct, but I think it's because the integer is being written all at once, and so
Right. So, but you're doing the opposite of what I did. I started with tag, and then I do the order, and then I just wrote the thing in the order. So that's how I got the number. So,
nice.
So yes, but it's smart, but not very smart. Yeah. So there you go. And the idea here is that you can like pass these files around and whatnot. But yeah,
which is also really cool. Like
yes,
what I was saying is like this is something where you can run it on a remote machine, get the file, and then do whatever analysis you need to do later on it, which I think is really cool.
Yep. And the other thing I want to play around once I have time again, because like starting a new job turns out that it's not easy. I don't know how you do it, but like this is the first time I start a new job after the other job. So yeah, I don't know. It's a lot. How do you start a new job, man? Like what is your strategy to start a new job?
Well, for me, I'm done starting new jobs. I think I'm just gonna chill out.
No more new jobs?
No more new jobs.
Really?
Which, I mean,
wow.
I'm gonna do like new little contracting things, but yeah, I think my main.
But that's new jobs all the time. That's new
it's
jobs
worse.
all the time.
It's new jobs at worse. Yeah. I think my main strategy is to like just ask a bunch of questions until I figure out what things are fucked and then try and fix them. It's my usual approach.
All the things.
Everything, always, all the time. Everything is terrible. And just like ask a lot of very pointed questions and be like, hey, do you think this is good? And just figure out where all the spiders are. But yeah, I don't know. It changes a lot based on how I like where I'm working. Like when I worked at Stripe, my job was like build a Python team, and I'm like, okay, I know what that means. At Sentry, it was like,
but even with that, how do you approach this? Because like the one thing that I noticed is that it's like if you ask people, okay, hey, you use Python a lot, and it's like, yeah, whatever, we use Python. It's like, so why is broken? Like, like what you don't like about Python? So if you do this question point blank, like there is no answer.
Yeah.
I mean, of course there is some answer, but like, but then it's like, oh well, it's not too bad. Like it works, and then you say, what about this? And they're like, oh yeah, that's fucking horrible. I was like, bitch, do you live like this? You know what I mean? Like,
right?
This is like, of course, but and they say, yeah, that's horrible. Please fix it. So the thing is, like, it's very difficult to extract. Like when you build the Python team, for instance, at Stripe, how do you know? How do you find from your, like, so you're jumping into a company that you don't know.
Mm-hmm.
Like, how do you know what are the pain points if people cannot point them out? You know what I mean? Like the hidden thing. I suppose this is more important when you want to bootstrap the thing, but
yeah. So in my case, like what I did was I found the teams that were using Python and I found their bug tracker, and I was like, I am going to fix a bug and figure out what things I think are stupid in this process, and then that's how I'm going to start my basis of like the foundation of this world. And so I found like it's like Stripe mostly used Python for data science stuff, so it's not really things that I know all that well. But it was like, oh, I'll find like this one ticket where they want to add an API endpoint somewhere, so I'll just go figure out how to add an API endpoint, and then realize just like, oh yeah, let's install dependencies. Oh, we're just installing directly from the public internet and without a lock file, and We build some library from source every time we install it, and it's just like all these things that are like, oh yeah, I've fixed that before. I've dealt with this problem before. I've dealt with that problem before.
Right.
But like going through the motions as a developer myself helped me understand their problems. But I also just went and talked to a bunch of people, and like, you're right. Like they've dealt with these problems so long that like they don't know what's bad.
Right. I think one thing that I'm enjoying a lot here is that everyone, I mean, I know it's kind of weird because a lot of people will say it, but like, if you know my work, you can believe me when I'm going to say this. Like, everyone here is super smart. So the amount, like, that's so cool because like you can, like, there is no, you know, I mean, I don't want to say that, of course, like in Bloomberg, everyone was very smart as well, but like,
Yeah.
like this is kind of a slightly different level. So it's kind of cool because you don't need to explain almost even the intermediate stuff. Like you just assume, I mean, sometimes, right? But like mostly ever, especially the people around me, like nothing, like it's just all same language all the time. And it's amazing. And also like, they're very kind and all, like, that's amazing. I mean, I obviously decided to switch because I like the people, but I've been really lucky to find really cool people that I buy with, even if it's I think a generation between us. So like, I don't get the jokes, dude. I'm all now, which I know like is becoming a joke on itself. Like how Pablo says it's all, but dude, like I just don't get the jokes. I'm like, oh, I mean, I get them, but it's like, I'm extrapolating that this means this. So like, but I will like, it's the kind of thing that I said, if I say it, it will sound weird.
Yeah.
You know what I mean?
Yeah.
Like okay, I vibe. I know what you mean. You know, 6'7". I mean, they don't do 6'7", but you know, whatever. And it's like, oh, okay. But okay, let me. This is not a thing that people say there, of course. But like, let me give you an example with 6'7". Okay. So I get it, right? I get it means nothing. I get there's nothing to get. It's like a meme by itself. Although it's like some fucking song or whatever.
Chat's losing their minds right now.
Yeah, but like the fucking thing, you know, it's just there. You know, it's like looking like a from the window. Like I'm not there. I'm not there. Like I can see it. I can recognize it intellectually. But like it's like stupid joke.
It's not vibing with you. Yeah.
Yeah, but and it's the kind of thing that if you do it, it will see like, no, dude, like now it's not funny anymore. You know, because you did it. It's like so it's kind of weird. It's a joke that you can only observe.
Right.
So yes. So I kind of feel slightly like this, which is cool because you know it's not new. It's new. It's like cool. Like you know, in my team there were not a lot of people that have this kind of, you know, we were all like having the same generation humor, which is good. You know, like it's kind of cool. But yeah, going back to the smart thing. The thing is that it's amazing, like super cool, you know. But it also exposes a bunch of interesting challenges that didn't exist before. Like everybody's too smart now, so everybody like has like a mega weapon, you know, and like now
a bunch
what
of strong
do you do
opinions
with the mega weapons? You know, like which is it's amazing because like it's a set of problems that like, you know, they are not like it's just you normally don't think about them. It's like how like imagine like this, right? Like you will say, well, most of the time it's like, oh, we need to construct something that solves this problem, and it's like, no, that problem is impossible. He is not like this. He's like we do all this mega advanced shit, but like now everybody can throw advanced shit at the problem. So like now nobody understands the advanced shit of anyone else. Not really, right? But like, and that's very cool because like that's the internet, right? Like I don't understand your advanced shit, you don't understand my advanced shit, but like that's a very nice new thing. So that's something that I'm enjoying a lot. Like, you know, the being surrounded by super smart people. And man, like, it's so much Python. Like, it's amazing. Like,
I was gonna say, amazing. Like, how much Python are there?
Well, I mean, you can read it in the blogs, and this is public information. You know, Python is very big there, and they do mostly like you know, Python, C++, like many finance people. But like, there is so much Python, even by Bloomberg standards, which we use a lot of Python. I mean, Bloomberg is bigger in number of people. Of course, they will produce more lines, but in percentage of what you see. But it's very cool Python. It's like, of course, there's, you know, a lot of data and whatnot, as you will expect.
Everyone is.
But there is a lot of infra as well. Very nice. And so yeah, very. I'm enjoying it a lot. It's very nice. It's also, you know, like the amount of info that you need to introduce to your brain in 3 or 4 weeks is a lot.
It's insane.
I don't know. I like the challenge. And I like my team a lot. So very cool.
Nice. That's awesome. That's great to hear.
Yes.
I'm glad you're continue to be happy at your new place.
Yes. It was a bit of a gamble, you know, because like when you are 10 years in a place and then you're like super effective. I mean, you must know about it, right? Because like I'm pretty sure you felt like this in your in your jobs. Like
Yeah.
you I mean, it's always, I was very lucky because for me it was never people, in the sense that like normally when you are feeling really well at a job or whatever, you normally leave because your manager or because the people around, not because the job itself. I mean,
Right.
unless you are bored, but like,
Yeah.
in my case, I was very lucky because I never had the problem with people at Bloomer, and you know, I really liked the job. It's just like, you know, it looked like this was going to be cooler, but it was a bit of a gamble, and I was like, okay, let's see what happens. I'm very cool. I was lucky that it didn't do well, but yeah, I suppose like, you know, when you do it 2 or 3 times like you did, is
Yeah.
easier like that to change. Like, do you
I
feel?
think I've changed 4,
Do you feel
5 times
the
now. No, there's.
5
I
times?
definitely agree with
Nice.
you. Like it's like you're like, well, I'm comfortable where I am, and like the people I work with are fine, and like the problems I'm solving are interesting, and then it's like, do I take the leap, and like what if it sucks ass? Like what if the view that I have of this other place is like so much worse? And to be fair, I would say that I would say that Stripe was not what I expected going there, and like, you know, I think like I did end up finding some like really cool people that I worked with, and like you know, some cool Python people that happened to be there too, which was really awesome. But like the expectation of what I was going to be doing and working on was completely different than what I ended up working on. And like,
Right.
so sometimes it's a miss. is what I mean to say.
Right. Well, right. Like I think, I mean, it's kind of like, I think also for the people that like us that put a lot of ourselves into the work, is very challenging, because like to at some point it feels like you're kind of like, you need to, I don't know, it's a violent move to detach yourself from something, and like, or to find that you are trying to put your roots into something and then you don't like it anymore. It's kind of like, it's a part of your soul goes to shit, and like it's a very emotionally violent thing to do. So you know, I always have seen like changing jobs as a kind of a risk in that sense, because like it can happen that like now you need to deal with all these fucking feelings and whatnot.
Yep.
And I don't want to have feelings. I want to do work.
Right.
But like, you know, yeah. So I understand, man. And also, it's not only that. Like, I suppose we share kind of a similar view on this. Like, it's also the amount of new people that you need to meet, right? It's just fucking exhausting.
Yeah.
Like, in the sense that it's cool. Don't get me wrong. I'm not saying it like, the people. No. I like the people. It's just like,
it's
dude,
just
like,
so much work.
You talk slightly different, and now I have this fucking accent, and you don't, and you're like, what? And I'm like, what? And like, oh no. And you know what happens? Like, you are a native speaker, but I'm not. So, and I have an accent, of course, not horrible, but I have an accent. And then I have like, I'm fucking crazy, right? So I have these expressions and this shit and whatnot. So and you know, there is a time for everything. So I know how to modulate that. But then there is this thing when like, I have to, like, the default level is like, this guy is an idiot. So you know what I mean? Like, if you go and meet someone, it's like, hey man, like, what's up? I'm blue. I'm like, hey, what's up? I'm Pablo. And then you say something, and the guy's like, what? And then you say, oh, what do you mean? And like, this fucking guy's an idiot. So you need to. So and man, I know. Do you know the meme when like I think it's Modern Family or something. I don't watch the series, but like when the lady says like, do you know how smart I sound in Spanish? So this is the shit. Do you know how smart I sound in Spanish? I mean, I sound equally crazy, but at least I don't sound like a fucking idiot. Like I can lead the conversation and I'm cool. But now in English, like, oh, what? Like, what the fuck?
Constantly reparsing.
Man, the other day. Yeah, it's horrible. And even like, do you know the and you know, if I put my 100% of my mental cycles, like I can be really good and you barely will notice. But for instance, at PyCon, when I'm fucking wasted, like just like destroyed, right? And or for instance, in the morning the other day, I was in the office and I was like doing my breakfast or whatever. And then some guy super nice when he's like, hey man, like, what's up? And my brain was like, danger, like not prepared for conversation. And I was like, hey, what's up? So tired. And then the guy says something like, yeah, I'm tired. Assuming you say that you are tired. I'm like, what the fuck is happening? I'm like, what is happening? See, like I was thinking, this guy now thinks you're an idiot. So it's kind of like, but I'm not. You know what I mean? It's very difficult. So now imagine this by 10. every day. So I did this thing when like I started to meet a lot of people to say, hey man, I'm Pablo, I'm going to like try to solve your problems, whatever. And then it's just a new person every half an hour.
Yep.
And he's like, fucking Christ, how could, it's really hard how to not look like an idiot 5 times in 5 times a day for a week.
Yeah.
Like it's really hard. Like, and also like everybody will speak differently. Some people will be super easy because like, and then like some people will like, hey, it's just like, hey,
that's it.
Like,
yeah.
so what? Hey, what's up? Like, like I was doing this thing when I said, I should ask everyone who I should meet. Then I will know the important people very quickly. I will map.
Graph problem.
Cool thing. Yeah. That actually worked really well. But then I expected a 100% success rate, but I didn't have 100% success rate. And you know what? Because some people were like, I was like, hey, so last question, like, who I should meet? And people are like, well, the usuals.
Like, that's not helpful.
I just started yesterday. Who the fuck are the usuals? You know what I mean? But you cannot say that. So you say,
yes,
thanks.
I know. I know who you're talking about.
And then you go, it's like, when that guy said the usuals, who are the usuals for them? Because it's different if you ask, like, the usuals are different. You know what I mean? Like, if you ask you will say, oh, of course, these guys. But you ask someone else, it's going to be different guys. It's like, what the fuck? So yes, like, that's the biggest fear is how to not look like an idiot. That's being a Spaniard. Yeah.
Yeah. I think the other problem.
The takeaway is don't be a Spaniard.
the simple fix, just simply do not be.
Yes, don't be a Spanish person. It's harder. It's hard mode in life, especially if you join in Spain. Well, if you're in Spain, it's also hard. Like, we're idiots.
I think I suffer from the same problem. Well, the same like meeting people problem too, in that like it's like try and not look like an idiot and try and not look like an asshole in like the first 15 seconds of what you're saying to them, but also like
exactly.
And then like try and understand their accents enough that you can like have a conversation and also still satisfy those first two conditions. But like for me, it's often like I need a pattern match with something I've seen before, and so like brand new accent, I'm like all over the place. But like as I know them more and more, I can understand what they're saying even if no one else can. And it's just like get these things, you pick up these things over time, and like but yeah, meeting people for the first time is like, oh, I'm gonna run all this.
Even the not looking like an asshole is surprisingly hard because it's very like I was really
especially if I am an asshole.
But like it's mostly like, okay, so it's just normal stuff, right? You join a new place and people do things differently, and it's like, okay, this is different, right? Or like, okay, so and it's the kind of thing that is not helpful, like, because I've been on the other side, right? Like people have joined my team or like the people around me when they say, what the fuck are you doing, guys? And you are like, yeah, we know, dude, but like it's like I hired this or whatever, right? Or like, or like, no, the reason this is because like this bullshit. So whatever, right? So most of the time, if you point out whatever is broken, it's not news for a lot of people, right? So
right.
But on the other hand, if it's news, sometimes people have the feeling of like having to somehow justify the status quo somehow, because otherwise, I suppose they feel stupid. I don't know how it works, but like it is generic. I'm not talking about any specific instance here or at Bloomberg, but I know it happens. Like even myself, like when someone says like, "Oh, okay, but why you don't do X?" and I'm like,
It's hard to detach yourself from the code or the actions or that other part.
Yeah,
really
the only answer why we don't do X is like, because we didn't think about it. What about that? So okay, but like, but sometimes it's not that you didn't think about it. It's like, okay, the thing was batshit crazy, and you allow it in some or just happen, whatever.
Yeah.
So I know of this. So I just know of this, and then I'm like, okay, so like people are so nice as well, because like at the beginning they say, hey dude, like don't drink the Kool-Aid too soon, like just point out all the shit, like that now is the time to say like what. But man, I also didn't want to join and say, oh, this is shit and that is shit, and like you guys don't do this and like blah blah blah, because like that is the easiest way to like not like people hate you. But even if you are new, like you cannot just say, oh, it's my first day. No, dude, like
can't make friends that way.
So yeah, but I also feel a bit weird because your engineer thing will like
You'll kick in and you'll be like,
It's
I want to
wrong.
make this better. This is like
Yeah, it's wrong. But then people know. People know. It's like the meta levels of the conversation. You know what I mean? Like the first level is that you say, interesting choice. How this happened? And then the conversation has another level, which is like, we know, but I need to tell you the thing, and on top of that, there can be another level, which is like, and I want you to fix it. So so you need to navigate these three levels while the conversation is flowing, and some people know how to answer that very well, but like with some people, it just like doesn't work. You need to feel for that, because otherwise you enter in this like weird conversation when they will like understand that you are pointing out things, because people literally told you like point out weird things, but you are not really supposed to point out weird things explicitly, because then you will trigger feelings, and like feelings are dangerous, or not dangerous, but you need to like the senior thing. So like it's a bit hard when you need to do that, like exactly yeah. Or like it's good but suboptimal or whatever, right? But like which is the case. Like I'm not making fun of this. It's obviously how it is. It's just like, and I have been on the other side, but like as a person precisely that is joining, which is the first time I do this in 10 years, it's like it's a bit weird, because the conversation is happening. Like what I mean? Like I'm pointing to you that I find this weird. Like it's the ChatGPT thing. Like when people like say fuck you, and they put it in ChatGPT, and it's like, dear mister, like I will encourage you to like start into like sexual activity with yourself or whatever. And then like the ChatGPT on the other side like translated and said, Pablo said fuck you. So it's the same thing, right? So the words sound like, oh, what are the but like the real thing is like, what is this, dude?
You're exactly right.
Exactly. Exactly, yeah. So then there is all this conversation, but when you don't know the person, the translation layer is wrong. So like now you're getting this like weird shit in. So I can give you an example. For instance, I was trying to point out something at some point, and I was like trying to explain something with dependencies, right? So it's like, okay, I think we can do better, blah, 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 blah. And I wanted to say something like, okay, this library can depend on this library. And I wanted to say that the dependency is an implementation detail for whatever.
Yeah.
And then I was explaining this, and I was like, I want to explain, this is what I wanted to do, okay? So I wanted to explain that the dependency is like whatever, and I can switch it for something else. And a version, when you do this, is that the dependency is not good, and then you switch it for something better, right? Very classic, no? You use a stupid database, and then, okay, so the way I explain this is like, oh, so imagine that you depend on lib stupid. and then right, so but then I was thinking, overthinking probably not the best way for the example, what I mean? Like, because like it's like
now that library
you depend
is
on
lib
lib stupid, I'm implying that you are stupid because you use lib stupid, you know what I mean? Like, no, what I wanted to say is that no, you depend on lib stupid because you are going to switch to lib cool, and it's just the fucking name of the library. But now the because we don't know each other, you can say, is he saying that I chose to depend on lib stupid because I'm stupid? It's like, is that the subtext? But of course it's not. Of course it's not. Right. But we don't know each other, so now you don't fucking know what's going on. So like, you need to be extra careful.
You have to tiptoe around, not hurting people's feelings because you don't know them yet.
I mean, it's very cool. Like I like it a lot, and like especially when like people are nice. Like so for instance, I've been very like happy here because like people are really nice, and like nobody has told me, oh, I'm stupid because I depend on lib stupid. Like no, like super cool. But it's still a place with a lot of people. So for now, I've been very lucky that everyone is nice, but like maybe someone is slightly less nice or whatever, right? So I don't want to trigger that in case it happens. So I'm always like, I'm having this conversation, but I have dedicated 20% of my CPU cycles. I have a thread.
The overthinking thread.
Like, yeah. The overthinking thread is like, dude, you say lib stupid. You're an idiot. Like that is risk level 6. Risk level 6, and like tune it back. And I'm like, oh shit. And like, so I'm like, so you see, I'm doing the explanation, but then I have the thread, and the thread trigger an event which is like, someone can think that you are saying that they are stupid. So now I need to make very sure that in the bounds of the conversation, I explain that no, I say live stupid because it's live smart later, right? So I need to insist that this is what you will do without having to explain that the reason I'm over insisting on this is because I thought that you maybe think that you're being a fucking senior engineer is shit. It's so complicated because like when you're aware of all the possible fucking mistakes you can do, man, when I was a junior it was so easy because you just go there and say, this fucking thing is wrong.
Yeah. You can get away with it.
Like,
but now you say that and someone's like, oh, Pablo says this thing is fucked, therefore we have to know that this thing is fucked.
But like, I got this at Bloomberg all the time. Like they're like, dude, like everybody's looking what you said. Like you cannot just say this is bad, you know? Like you cannot just say this. Like, but it's bad. Of course it's bad, dude. Like we know. But like if you say it's bad, then the person will feel bad. And like no, like because you must grow the teams around you because you are in this position now, like staff or whatever, and like you know, like now you're growing teams, so like you cannot just say it's bad. Like that is forbidden now. Like you cannot say it's bad. Everything is good, or like everything is.
Yeah,
you know what I mean.
It is because of the way that it is.
Exactly. Everything is, and then your fucking job is to make it better, and that's it. Like so don't say it's bad. Just chop. So exactly. So being a junior, listen, chat. If you are juniors, it's the best time of your life. You can be idiots, and you have a bunch of like passes. You're
allowed to be dumb.
Sorry, I'm a stupid junior, and then you can learn so much, and like you can do all these stupid questions because you see, there are no stupid questions. That's what everybody says.
Well,
but the reality is that they are stupid questions. so sorry to break it to you, chat, but like yes, they are stupid questions, but they only happen when you're a senior. You see, when you're a junior, no stupid questions. You can ask all the questions, and none of the questions will be stupid. But when you're a senior, now you are in the realm of subtext. This person should know this. If the person is asking this is because they want to secretly do the thing, and I don't want them to do the thing. So like, so no, it's fucking annoying. So you need to think about it, you know. But when you're a junior, whatever, dude, just ask whatever. Like. You know, isn't this stupid? And people say, haha, yes. And you know, it's so easy. But then later it becomes like complicated.
Yeah. Like I have like a very concrete example of this at the contracting thing I'm doing right now, where one of their tests takes 20 minutes and blocks their deploys. And so I was like, how do I nicely say that there's no fucking reason a test should take 20 minutes? But I had to like very much dance around and be like, how did we get to this state? Like what problems are we solving with this? Like how do we go about debugging this thing and like trying to be very professional while inside screaming and be like,
will it be like
how do I delete this thing? Like...
Yes. Is this really valuable? Like how much value is this test providing? Like, you know, has it found many bugs? You know, also like I something that I miss because not because I cannot do it here, but like because it's new. Like I got into this super cool pattern where like you will make a PR just to show something. It's like, hey, dude, like especially when you are like remote, it's very cool to just like say, I have this idea, or like I have a question. Like for instance, you know, there is this problem, and then it's unclear what is it's a regression, something broke. But then what broke, it was some fucking assumption that someone made that is just squishy, like it's very difficult to put into code. So like now you have the classic test when you will hard code a bunch of shit and it's like, this thing must not break, but like now you have a bunch of fucking functions. So if someone has a function like whatever, or you can go mega bananas and say, I will freeze the state of every fucking thing in such a way that if you change anything, you must update this. But which is annoying. But then you will say, I Pablo Galindo willingly opt into not like this happened. Like you know, I know this happened. Good, I allow it. So, and then there's a command or whatever. So I'm used to say both. And here is how it looks like. And then someone says, oh yeah, this is not. Let's go with the other one. And it's just normal. But then when you know someone and you don't know this deal, like people are like, like, do you want both tests? This is insane. Like,
no, they're options.
Like,
they're options.
No, it's just to start a conversation. It's just options. Like, this is how it looks. Like, like you just select one. So getting into, or for instance, with Matt, that I think you know, Matt Wodniski, he's my colleague at Bloomberg, smartest guy on the universe. We used to have a flow which was exquisite. It's just the fucking best, like flow on the fly, which is like I made a PR, and instead of reviewing the fucking PR and put a bunch of comments, and then I will fix those comments, he just fixes the fucking PR, and that's it.
It's so much better.
It's like here's a PR. Yeah. So I trust you. So it's like we are now linked by the power of our minds. And now, if I will trust you that if you are going to do something that you think I'm going to dislike, you will write it and say, hey, dude, like, what do you think about it? But if it's something like, I don't know, you fucking care about, and I don't give a shit, and I trust you to understand which one is which, like just fucking
do it,
go
bro.
and like fix it. Yeah, it's so much easier, dude. And like bam, bam, boom, 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 and done. And chop, something else, dude. Like mama, and like so amazing because like you don't need to do like can we move this line?
I believe that you should be doing
like no. Just like do like or like we should re-architect, just fucking re-architect, you know, like I don't fucking care, like just do it, and like, you know, boom, boom, and like to do it, and that's it. And then if there is something bad, it's like, oh, should we do this? Oh, I think this, blah, 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 and then I do it, and that's it. And then I review the review and merge. Dude, it's 2 days, amazing, bop.
Easy done. We actually have a meme for this on my stream, which we call it "Good Code Changed Like a Ghost." And it's originally from like a terrible copy pasta of somebody being really mad at pre-commit and like doing this big long issue. But oftentimes when I'm reviewing open source PRs, I don't have time to tell them to fix it. I'm just gonna fucking fix it for them. And so it's
oh, I see. Yes, that's the best way. 1 second, I'm going to put this table, or otherwise I will disappear like a ghost. Yeah. Okay. Yes. I was unplugged. Yes, the best way to do a stream, like not having a power source. But yeah, exactly. Sorry, go ahead.
Oh no, that was it. That was just the stupid.
So yes, I don't know. Like I will still like take a bunch of time to just get up to speed. But yeah, I don't know. Like I'm still around, but maybe not like December, like when I was doing like crazy things. But yeah, what do you think about the profiler, man? Like,
I'm so excited. I'm so excited to be able to use it. I do think that the command is a little bit clunky, and there is one already. There's already one that seems less useful. Let's see, grep bin. Yeah. Like, there's no way that we need get text as a binary. Like, surely we could add one that's the profiler, right?
Okay. Can we talk about possibilities? Let's talk about possibilities. So I was confused by the following thing. Okay, I think I can convince people. I don't think it's too controversial because that get text, and then that's because you don't have installed the other bullshit in Debian because you split it. But if you do a normal installation, you also will have idle, and you will have pydoc. I think pydoc.
Yeah, I have pydoc also.
Yeah, and a bunch of other shit. So I think it's fine. The question is that if you create a virtual environment, that shit doesn't end in the virtual environment.
That's true.
So the question is like, do we want to put this on the virtual environment, and then it will be fully qualified? You see, now we're starting the real questions. It's like, what do we do there?
Yeah.
Because
yeah, you're right. Then it gets fucky because then like the VM module has to handle it, the third-party virtual env has to handle it, and like we've already done that.
It's not the end of the world. It's not the end of the world, but you see, like being a core dev sucks because like you have a project and then you say, I will fucking put it in the folder, like it's like my folder. But now it's everyone's folder. So
yeah.
So
is the problem that the profiling module name is too long? Maybe.
Okay. Yes, but like, dude, not my like. I'm you think I have the keys of the car, but I don't have the keys of the car, man. Yeah. Like
I saw the fucking cred for the
council. Pablo's on the steering council. Let me tell you something. Pablo's in the steering council except for his shit. Yeah. So like, exactly. So my proposal, if we go to the original thing, was that it was not going to call profiling. It was called to call profilers because I think it's cooler. And also I wanted tagging, like just minus m tagging.
Yeah.
But like no. Profiling without sampling. No alias. No alias. No.
Can't have nice things.
So yes. I will try to fight the battle. I don't think maybe Hugo will be okay. Maybe I don't know. Hopefully we don't need to go to the steering council to put a file in a folder. But I don't know. Maybe it will be annoying. Maybe not. What else do you don't like apart from the fact that you need to write Python -l profiling at some point, which sucks?
I think the only other like gut feeling is profiling.sampling is that the help is a little overwhelming. And I do like that there's like good examples for not doing run -- help. Like there's a few that are probably the things that you would want to get out of the box. And it might just be that I haven't worked with it enough to really get a feel for all of the options, but like that I have to scroll up to find the useful ones is always kind of annoying.
Yeah,
some
like the thing is that
hobbies.
one problem that
Greetings
this
to W.
has, as you
Pablo.
can see, okay, maybe you can help me here because like I keep going back and forth. Okay, so think about there's a problem here, which is that run. So run has this thing when we discuss when like it tries to just create the file. So
Yeah.
no fucking intermediate thing, just creates the file.
Yeah.
But the problem is that now some of these options take options. So for instance, async mode only goes with async. pstats has a bunch of short options, and this is the flattened namespace of all the fucking options.
Yeah.
So what happens if you try to pass I don't know, gecko and a limit something, it will tell you, no, that no,
doesn't
bad
make
boy.
sense.
No, my friend, which is annoying because RParse doesn't support this easily. Because you say, oh, but Pablo, no, it does support it because like that's like groups blah blah blah. No, it's not groups blah blah blah. It's not groups blah blah because that you will need to duplicate the entire fucking shit. It's like, have you ever tried to add verbose in such a way that works for all the subparsers?
Nope.
It's very fucking annoying.
I've never gotten it work properly. I've given up every time.
It's fucking annoying. And exactly. So if chat, think about it. If this guy has given up and I have given up, like everyone
has given up.
Like
yeah.
it's just like, yeah, not possible. So okay. So the only way I can think of right now, as of today, to make this not like this, is to go into the memrate workflow when like run just creates a file, and then you will have a subcommand for every possible output. But that sucks.
Yeah, then you have subcommand hell.
So this is what memrate has taught me. Memrate, PyStack, and other tools. You must know this. Let's see if we agree. This is the insight. Chat, listen to this. Very important. This is this is stuff engineer insight. So this is the insight. You that are very technical. Like always think that the core of this shit is what matters. And like I'm saying a lot this like 1 megahertz, 1 million hertz because for me that was so fucking hard.
Yeah.
And I fought so hard to do it. But it doesn't fucking matter. What matters is that the fucking HTML is quick to produce. Because like people hate the fucking file. It's like, oh, and the file, and how do I get the other thing? Like I just want the fucking answer, like I don't want a file, I want the answer. So the UX is half, if not more, of the experience.
At least 3/4 of the experience.
Yes. Do you even give a file? Like, do you even know what is the good sampling rate? Could you even distinguish a 1 kilohertz from like half? No. It doesn't fucking matter. But what it matters is that now, if run produces a file and then you say, what do I do with this fucking file? Yeah. And then you open the file and it says like, this is what file used to say? It's a LiDAR. It's a LiDAR. Yeah, can you imagine like it just drops a file and then you do file and it says, oh, here is a LiDAR binary format for like, the military. It's like, what the fuck is this? And then you're like, oh no. Do I need to pipe this into flagra.pl? Like that is the worst experience.
Figure out how to get
experience. It. No. Yes, like I need to clone Brendan's Greg, which is the most cloned repository on the fucking planet because like nobody which is ridiculous, man. Okay, I have to say this. Sorry. So think about it. This is the cosmic humor. I love it. Think about it. Everybody on the planet that uses perf, the Linux profiler, is people like that are insane about performance. Like we must performance. But all those people are fucking like piping their output to Perl.
To Perl, yeah.
The fucking like slowest language on the earth to produce the fucking language. It's just cargo code. It's like, how do you get a thing out of dude? Do you want the cosmic joke? Perf, the Linux tool, as of today, supports getting a flame graph out of the box. And it's not documented. It's not documented. Let me say it again. It's not documented. Not only is not documented, even if you know that it's there, it's the command line is so fucked up. It's so fucked up that it's impossible to know what was the fucking correct way. So just for you to know, it's perf script flame graph, but perf script is its own thing. So it will, if you give a file, it will vomit the fucking thing. So you say, oh, perf script does that flame graph? No, wrong option. That doesn't exist. Like, perf script help. No. Like, so what the fuck? But it's because perf script has a positional argument which is optional. We will take a Python script. It will take a Python script relative to the perf repo. So it's only the ones that they have. You put like perf script blade.py when plays a file. No. And it's not py anyway, it's just flame graph, and then it will put flamegraph.py, and then it will open that relative to the fucking thing, but it will not tell you that they exist. So that's why you cannot have it, because if you do that help, it tells you perf script thing,
but you don't know what the thing is.
What thing? And like one of them, the usuals.
The ones you know.
Yeah, and then you're like, fuck off, dude. Like, which ones? And it's like, and actually, it's a very nice flame graph, like, D3 and all. But like, so nobody knows, and as a consequence, everybody fucking like pipes to Perl, and like, and then generate this other stupid SVG when they don't need to. But like, all these C++ people like must do the ritual of like fucking downloading the repo of Brendan Gregg flame graph, and then pipe into fucking Perl. This is the cosmic joke, dude. It's the cosmic joke. It's like how it is. But you see, again, going back to the profiler, what I wanted is that you just get the thing. So if I force everyone to have a nice CLI, when like you have like membrane, right? Membrane flame graph. But I know if I add tachyon flame graph, then for consistency, I will need to make run just puts the binary file. Yeah. But then that sucks. Apart of it's slightly slower because like if your disk is shit, then like it will be slower because it's just serializing to disk.
Yeah.
So I just don't know. I don't know, man. Help me here. Like I just don't know what to do.
So one bad idea is, and I'm actually, spoilers. I'm maybe rewriting pre-commit, and pre-commit actually has the same problem with runs help, in that it's a million options and nobody really knows which options they want to use or don't want to use. And I try and put the useful ones at the top, but I'm experimenting with an idea where there's a short help and a long help. Oh, I don't have it built. Okay, never mind. Where there's like a short help and a long help where it shows like just the common options, and if you really want, you can get all the other ones. But I don't know how you would split apart the common and uncommon options in Tachyon.
Yeah, he is difficult because because like let's say you want p-stats, like maybe you can have p-stats help or something like that. I will show you the p-stats one, but like even just opcodes and more like async aware and whatnot, like, well, I mean, you can see other things that it does. Like we didn't even talk, like that's a process, so you can like profile all the children.
That's cool too.
I think we
didn't touch on that. We talked about threads, but this is that's super nice.
Yeah, so processes also works with the like any child process that is Python as well, even if it's not forked, by the way. So if you are on macOS and it uses POM, it will track them.
Oh, nice.
Yeah. Do you want to see how that is done? Go. I can describe it. I don't know if it's super worth to look, but there is a depth first search on the process tree. So like it uses the OS APIs to list all the fucking processes, which will say, oh, but in Windows, in Linux, it's so easy, dude. It's just reading for procfs. No, dude, it has to work on macOS and Windows.
Wait, does this mean there's like a PSUtil?
Dude, okay, I must make an announcement. Fucking Windows, you guys are the worst. Like what the fuck? Like what the fuck? What the fuck? Okay, so you see this option here that says mode CPU, right? Like you can check if a thing is on CPU. So if you do now in front of everyone here, cat proc self stat. So cat /proc /self /stat. So the proc file system.
Yep.
Proc self stat. So here we will see that and then you can. So here you will see like a bunch of shit. But that R is the magical letter that will tell us if the thread is running. And you say, oh, but Pablo, that's the fucking like process. What about the threads? You can do cat/proc/tasks/ whatever is the PID /task, and then you can see the same thing for the threads. So you parse this bullshit. So self tasks, and then the PID, and then stat. That's a folder. Well, in this case, it's a bit complicated because you're cutting yourself. Yeah. So there is a bunch of symlinks, blah blah. So you do a little there, you will see there is a symlink, and then that will give you the thing. No, yeah, there you go. So yeah. Oh, okay, that's very good.
Oops.
Time. Yeah, there you go. Oh, yeah. And then run, for instance, or start. Right. So now if you go to that place, yes, you can do ls first.
Yeah, and then
task. Yeah, and then you put the entire thing. You will see that you have stat there.
And it's sleeping.
And then yeah, amazing. Wow. So you see trivial shit. You see, amazing. So easy. Well, I mean, so easy kind of, right? Because like you need to do some depth first search because this is just the thread. So the process is just another deal. But Windows. Do you know how you must do it in Windows?
I have no idea on Windows.
So first thing is undocumented. Oh no, it's undocumented because the only thing that uses this fucking code that is official is Task Manager.
I was gonna say it's probably this bad boy.
But then the API is so it's so fucking like how do you say? It's so attached to Task Manager that the API doesn't take the fucking thread as the input. Here we are seeing hey dude, like go to do this process and then go to this thread and then tell me if it's sleeping. You see, like the process thread. But no, Windows doesn't do like this. The only way to do this is with a handle. And then you say,
of course, yeah.
What the fuck is a handle? How do you get a handle? You know how you get a handle? By iterating over all
every
processes.
Process, yeah.
All processes. So the only way to... So Takion does this every sample. It iterates over all processes on the fucking machine until it finds your fucking process. And then it can list the threads.
Oh my
you
God.
See? Whoa! So Takion will be proportionally slower to every... Like, the more processes you have. So the more processes you have... I mean, it's just nothing. Okay? So it's fucking fast. It's just the memory... like, very fast. Okay,
but it's annoying that you have to do it.
But it's like, why do I need to do this? Like, it's so fucking ridiculous. I don't want to do this. I just want to give a fucking like a PID, and it's like, dude, give me the threads, bam, and it's like, give me the status, bam, and you know the worst, because it's Task Manager private fucking headers.
Yeah,
it's coupled with the thing in such a way that there is a circle dependency. So if you include the header, it blows up. You include the header, boom, it explodes. Because Task Manager is linked with like some fucking like idiotic technology, and then like it just like solves the cycle somehow. I don't know what the MSBC compiler does, but if you try to link that header with something that is normal, it just says no, because there is a cycle, and then you say hey, but there is a cycle, and they say it's a private header, dude. Like, it's your fault. And they say, come on, man.
Fuck around, find out, right?
I'm a profiler, dude. Like, no, your kind is not allowed here. Find out. You know, like, just do your thing. Not a Microsoft approved product. So it's like, okay, I suppose I cannot do it. On the other hand, like some other things, by the way, just to give like, you know, some good, some bad. Microsoft has the easiest debugging experience in the planet.
Like, oh my God,
doing
so
the debugging.
Nice. Like, Visual Studio is amazing.
Really good. I'm really good. Like the fucking MSBC compiler will put these no-ops on top of your functions, so you can like hook the functions. Like, amazing,
super
amazing,
nice,
amazing. Then there is all other questionable decisions, like the ABI for C++ for the destructor is an enum, so you have like 6 subclasses. It's not a virtual function, it's a fucking enum telling you whatever the subclasses you are, and then you switch depending on it, and it's a switch of all the subclasses. So like you know, maybe not the best, but like, you know, but then the debugging, debugging, exquisite, amazing. Microsoft people debugging, it's the best thing. I just want the API, the secret API for profiling. Just give me the secret API for profiling. Don't make me list every single thing. Like, no, That's horrible. I don't want to.
Yeah.
But yeah, that's how Windows works. And macOS, you know how macOS works? macOS works even worse because macOS has two functions. One of them takes a PID, but that doesn't have the status of the thread. No. By the way, none of this is documented. But like in macOS, nothing is documented, so like it's fine. It's just how it is.
Good luck, have fun.
So there is two exactly. So you just read the Apple sources and until you see something that you like. So there's a function that takes the PID, and then you say, so easy. No, because that one doesn't have the status. Oh no. But then there is another one that has the status that is called, but it doesn't take the PID. It takes the task. It's like, what is the
What's
task?
The task?
Yes. So who talks about task? It's the kernel. So the kernel has something called task that is not the PID, because you say, is the task the PID? No. But then there is this function called get task, and then you pass a PID and it gives you the task.
Okay.
And then it gives you a number. But the number is suspiciously close to the other number. It's suspiciously close to the other number, and it's and it matters because when you call the other task, it's very slow, but really slow. By the way, it's like stupidly slow. So like you don't want to call the other one for some reason. I mean, it's slow. It's milliseconds slow, but like for the profiler, you cannot do this on every fucking sample because then there's no 1 megahertz.
Yeah.
So
you say, that 1 megahertz is not happening anymore. Yeah.
Exactly. Like just check the fucking number, and then you say, what is this? It's because the task, the mysterious task, is a pointer to the internal structure of the thing. Yes. So in theory, and you say, wait a minute. macOS has this like mega nuclear. Yeah. They need to do this. Like they have this mega nuclear like super cool profiler that they ship called Instruments, and like these people need to call this. So I was like, certainly the code of that is not public, but like they have this Apple macOS GitHub organization with the linker and a bunch of shit. So I was like,
I wonder if that's
how they do this. So you know what they do? I found it. You know what they do? They add a mysterious offset. It's like you grab the task and they don't call the function. They add a fucking offset, a mysterious offset that they have a hard coded, so they know how big is the structure. They know how big is the structure, and then they say boop, and they just fucking move the thing. And I was like,
that's crazy.
That is insane. It's insane.
I thought they would have at least like called it once and then computed the offset, but no, they just hard code it.
So that's what I do. So exactly. That's what I do.
Okay, it's like you do the smarter way.
I subtract. Yeah. You can check the code. I subtract the number, and then I say I think I do it 2 times. So the number is the same. I then just use the number. Nice. Otherwise, but I don't assume the number. I just like. There is a number.
Yeah.
And I think Austin does a similar thing. So we all do the same thing. Just because Apple is stupid. Apple is stupid.
Wait.
So yes. You see, you want to do profilers and then you need to do this bullshit. It's like,
Wait, my ears are turning.
How do I get this?
Now that you have to deal with cross-platform process and thread management, does this mean that I don't have to use psutil anymore and I can use just some random...
It's secret. You could do that, but it's secret. Yes. If you go to... So go to lib... profiling sampling, no? So lib profiling sampling. And yeah. So you go there. Oh, you need to switch the... okay, sorry. I
switched
will
scene,
change it from the past.
Yeah.
So, and then you go to child monitor. Wow, child monitor. I think that calls the secret function that you want. Underscore child monitor.
This one, get child PIDs.
Remote debugging. Yeah, get child PIDs. Yes, that is the magic function.
Oh, cool. So they do exist there. Nice.
I think that the magic function will. Can you pass like a stupid PID that is not just some random PID?
Yeah.
And then you recurse it through. I think I filter the ones that are Python, but I'm not sure actually.
I'm
so
done.
Try to. Oh, but like no, pass a remote debugging. No, that's the module, no.
I did a dumb thing.
No, but pass a like a PID 1 or whatever. No, but like just pass a PID that exists. Let's see what it prints.
Yeah. So we get a list.
Yeah, PID 1, yeah, and then recursive true. You should get like all the processes in the machine.
Yeah.
No, but pass 1 and then recursive true.
Oh.
Recursive equals true.
Yeah. That's a lot fewer processes than I expected to be.
Well, okay, so it kind of works. Okay, so if you don't have sudo, probably you will be missing a bunch. But yeah,
Oh, I don't.
those are the
It's
ones
not root.
that
That's
you have
why.
access to.
Yeah.
Yep.
Let's copy paste this.
In theory, I should give you more.
Oh, it's true by default. Okay. Yeah, no, that's why. It's true by default. So what I need to do is false instead of true. Okay, that makes sense.
Oh, okay.
I understand.
Makes sense. Yeah.
I should have read
All
the
right.
default.
So secret function. In theory, you can implement most of or a bunch of psutil on Windows, Linux, and Mac at least, because psutil works on like all sorts of other platforms. But
who cares
yeah.
about those other platforms, right?
No, exactly. Yeah, exactly. You didn't hear this here, but yeah, I'm not doing profilers for those other platforms. Like I can tell you that.
They're tier 3 support.
Windows is already. It's also like Windows is already weird, man, because like it's like wide strings and a bunch of like it's like you need to learn a new world. Like even the C that you will be writing, it looks different. It's just like with all this like macro nonsense and like blah, like it's just weird. It looks like you're doing games or text editors or whatever. You know, like it's like what is this, dude? But yeah, okay, cool. So I have like 10 minutes more, but so what I would like is that, especially you, but if anyone in the chat as well, like you can play around, maybe think about the CLI. I'm pretty sure that once you start stress testing this, you will see like the seams. So like you know, just tell me what you see and what doesn't work. Some of them will be unfortunately inherently to the nature of the beast. So like it's just a sampling thing. So the most of the skews of this thing is that if you run it for enough time, those weird things will disappear. On the noise. But like there is we talk a bunch of the things like blocking, non-blocking, async, blah blah blah. The secrets, the overhead. I think we mostly cover everything.
I'm excited to kick the tires and play with it, and I will let you know, and my viewers will let you know what sucks.
Yes. My objective here was to make the best Python profiler and the best profiler ever, because like I think profilers suck because it's a very difficult thing to do. And every fucking language needs to deal with something different, and Python is one of the hardest cases because like it's heaps data. Like normally when you do profilers in C and C++, it's the stack. So like you unwind the stack, which is very hard, by the way, don't get me wrong, because like you need to deal with the information and dwarf and shit. Like it's just like another deal. But on the other hand, you have many other powerful tools. For instance, you have perf events, which is like a bunch of syscalls that help you to do this. So like it's a different world. But Python, you need to do this nonsense when you copy and the interpreter is moving and the interpreter changes and like fucking things. So, like this is very hard. But I think I wanted to. I wanted a profiler that is very easy for people that just want an answer and just like don't fucking care about anything. So just give me the answer. But I also wanted a profiler that like people like you or people that know what like a lot what they want to like do, and like they want really powerful visualizations, like we saw in the Gecko thing and the opcode stuff, like and whatnot. They can also use it as their only profiler, or like the one that they know that they always have. Of course, like if you still like PySpy or Austin or whatever, like those are excellent profilers, so just use them, of course. But I just wanted this to be like a really really competitive thing, and in my North Star is to make it the best. But that's something that everyone must decide what is the best in their book.
I'm also I just want to say again, like I've seen so much shit today that's like going to be life changing in how I profile code, that I'm really excited to use this more.
Amazing. Well, if you by the way miss any, we are still like on alpha 5, no? So we still have a bunch of like time. So
before the
Python,
freeze,
I think is when we do it. Yes. So if you miss any, I know that you like the dot thing. So that's why we added the pstats output because like that's the bridge.
Mm-hmm.
So we probably won't do some built-in dot whatever because I don't want to build like the
No one wants
mega
to build dot, yeah.
gel blah 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 that deals with the cycles and all that. I don't want that.
Yeah.
But if you are missing any visualization or hearing this, we're going to change slightly this thing because for instance the logo is taking too much space and there is a bunch of feedback that we already have that is UX related.
Also, how do I
like
navigate out of where I am right now? Because I noticed that was something that I was struggling with.
You can either click the root or I think there is a reset button in the top right where my face is.
This one. Yeah.
But you click main, you will but I think
or
there's
I can
a
do
reset
this. Okay.
button. Yes, yeah, that's how you do that. Maybe and there is a help somehow. I think. Yeah.
Like escape.
By the way, we didn't mention this, but this is very cool. If you click main right now, so you see all of them.
Mm-hmm.
Okay, this is very cool to show. Hopefully it works. Okay, so this is also very cool. Ivona did this. So you see here, this is a perfect case. So this is the async.io. So it's kind of different. It means something else. But imagine that this is a normal one when our application is spending time on those 4 sleeps, but in different paces. So like there is a bunch of different possible paths to it. But the sleep is actually the most dominant function. The problem here is that because every sleep has a different path to the root, it appears like 4 different times in different trenches. Here, we are just lucky because they are aligned, but you can imagine that the paths will be different.
It could be askew,
they will not be in the same row. So and imagine that you want to say, well, okay, but I just don't fucking care about like the path to it. I just want to know the function where this is happening. So you see just below the logo, there is this toggle that says inverted flame graph. Just below the logo of Takim at the top.
Oh, yes. Okay. This is super
So you
useful.
click that. Yeah, it will not flip it. It will basically reverse the stacks and then aggregate in the opposite direction. So now the root appears many times, but the sleep is now collapsed. So this way, even if a sleep will. So this is very cool because, for instance, you can imagine a case when like this sleep is just really, really tiny. Like you're calling it for almost nothing, but you're calling it a gazillion times. So that's a bug we're fixing the width. The width is when you flip it, the width is limited for some reason. We will fix that. But the idea is that when that happens, like a sleep will be like really, really, really small calls. But then when you sum them together, it will be a huge chunk. So with the reverse, with the inverted flame graph, you will have a single bar for all those chunks. So you can see that, sure, every call is very small, but all together, even if they come from different parents, they will be different ones. So that's something that we want to experiment. The other thing that is in the pipeline that hopefully we get before alpha something is that now that we have files, something that we are playing with is that if you have 2 files, one for like baseline and another one, it will do a differential flame graph.
Sweet.
And the idea is that it will show you kind of like the functions that go faster, the functions that go slower, and then separately the functions that disappear.
That'll be huge. That'll be so good. Exciting.
Yeah, so you can like you can run something and then you can run your best version of the something, and then you can check very easily. So you don't need to like open both and kind of
eyeball
like,
it and squint and see what
it. That's very annoying. There is a bunch of like we are playing with UX for this because you can imagine all the cases. It becomes very weird very quickly because what happens if a function is in one but not in the other? Yeah, like how do you imagine that, I don't know, an entire block like an entire function disappear.
Yeah.
Is that 100% slower or like 100% faster because it disappeared? So we probably want to just show B minus A and then show the things that are not even in B separately. So all the negative counts will be in the other one. So you could have like kind of like disappear flame graph and then you will see all the functions that are no more, because you can imagine that you could have a case when like you say, why are we calling this is stupid, and then you remove it and then your thing is faster. Of course it's faster, but like it's because the other thing disappears. So it's not because a single function got faster, it's just like you're doing less. So you want to still see this. So we will have this like toggle when we say, functions that are no more, and then we will show like the functions that go faster.
Cool. Yeah, I'm excited for that. That sounds, I mean, I've spent so much time just being like, what's different here? And like having an automated view will be so powerful. Well, Pablo,
unfortunately, I need to go. But thank you very much.
Thank you for coming on. This was really awesome. I learned so much today, and I'm going to be rewatching this because I know I'm going to find something that I completely missed. Like you said, the fire hose of information. But thank you for coming on.
Well, thank you a lot.
If there's ever anything else you want to chat about, like, feel free to just hit me up, and we can do this again sometime, because this was really awesome.
I felt like home, so thanks a lot for the super nice time, and thanks for dealing with my Spanish accent. Very easy, very easy. If I have to, meet with you like 5 times in the same day, I will do it. So amazing.
Awesome.
Thank you very much, and thank you the chat. We will see in the future, whatever.
Sounds good. Thank you so much, and you have a great rest of your day. And bye, chat.
You,
have a good one.
Cheers.